massive thanks to all of my supporting members and patrons. Thank you all so very much.
Shut up and sit down.
I didn't forget my sound. Hello, good evening and welcome. We got a hell of a delay tonight. Hell of a delay. It must be Zoid's hamsters, which is why this stream got delayed. Apparently he's run out of electric, or Sif Ifrica has run out of electric. Never mind. Yeah, I wanted to talk to Flatzoid. He'll be starting in about 10 minutes. I've got his stream open, so hopefully it's this just under 7 minutes now, and then he'll jump in and we'll give it a go. So I'm going to have to do a bit of tinkering with that. That's a bit better. I like to hear my voice, my dulcet tones. Hope you're all well, smiling, enjoying the weather, unless you're in California. Bit grim there, isn't it? So Flatzoid, I have noticed that flat earthers currently are starting to eat each other. Originally, the first one I saw was Flatzoid and Dell arguing about upwards accelerating Earth. So I do want to talk to Zoid about it. It might be that I don't disagree with his position at all. I want to find out what his position is and talk about that as a general sort of thing. But there's something else I want to ask Flatzoid as well. What's this? I'm a mod and Chuck isn't. How did that happen? Who's Chuck? Chuck. Good evening, Cygnus. Brian Pop Robson, 9 o'clock hero, Flow Rider. Actually, there's something that should happen. Flo, you are a mod. Anyone who's not a mod, don't ask, because it won't happen. I apply mod ships at my whim when I fancy it. I like to apply people who I've seen around for a long time, who I've built up a relationship with, though not in the biblical sense, and it will come out the blue. If I'm going to mod someone, it will come out the blue. Now, there's plenty of other people here who've been here a long time as well. I'm trying to pick someone at random. Pincho Paxton's Greatest Minds, for instance. He's not modded. That's nothing against Pincho Paxton's Greatest Minds. Just haven't decided to mod him at this point in time. And we might have the squeaky hamsters. Give it a go. So if you're not a mod, don't worry about it, because actually, being a mod is not necessarily a lot of fun. I know. I've been a mod, or am a mod, on several channels and Discords and so on. Oh, Dr. Nimrod, member for 10 months. Well, who'd have thought I'd make 10 months? Well done, you. And I hope your cat's okay. So I'm just now seeing myself pick up the aircon controller. That shows you what the delay's like. It's not good. Tim Tech Dude, what if I send £50 cheque for a mod status? That'll help. No, it won't. But I'll have the 50 quid. Thanks, mate. Oh dear, oh dear. Yeah, so it's been quite interesting seeing some of these flat earthers start to have a bit of a go at each other. They can't agree on the shape of the earth. They can't agree how the earth works, the sun works, shadows work, the moon, planets, stars. They can't agree on most things, really, except that they don't like things that are globular. Globular. Go figure, because I can't. Thousands of years we've known it's a globe, and haven't caught up yet. The secret is to bang the rocks together, guys. Yeah. Brian Pop Robson. Hello. Who is this M2M bloke? Never heard of him. No. He was in here earlier on. Oh, and someone tried posting a link. Sorry, I do apologise. I can't recall the name. I'm scrolling back on it. It might have jumped off the top of the chat now. Because you wanted to post a photograph. If you want to email it to me, mr-sensible@hotmail.com. Send me the link. I'll check it's all okay, and then post it. Second best Bob, member for 36 months. That's 3 and another 6 months more than you, Dr. Nimrod. Second best Bob, how much months? Great to have you back live. Thank you very much, Bob. Yeah, I did a live the other day and I really enjoyed it. It's been good for me to get back. It's not been a happy time, but let us not be downhearted siblings. One total disaster is just the beginning. What's this? I've got text overlaid over text here, so I can't read what's... Oh, there we go. Cygnus TSP 2747. 27 is in the house, as well as Chris P. Bacon. It's good to see so many of you guys. So many of you guys here. I hope you enjoyed my old expedition, Flat Earth expedition to Bournemouth video I posted, because I realised that was so long ago that at that time, I don't know, I might have had, say, 400-500 subs. So most people, other than those few kind ones who decided to binge watch everything, and it has been done, most people won't have seen it. And I thought, do you know what, why not? I really enjoyed that day. When I saw it, I sat and watched it, and I laughed at myself. I did. Because I haven't... Oh, it sounds like Flatzoid's stream is just starting. His hamsters are running, the wheel is turning very fast, generating some of that nice fresh electric. Yes, I guess he'll be in here soon, so I shall keep an eye out for him in the Discord. Yeah, and what's the other thing that's been going on? Mr. Lucky Haskins. Yes, fistful of stupid, no less. He's been giving me all sorts of demands about things I need to do so that I can debate him live. He was telling me I have to post his response video on my channel. Well, how does that work? I mean, occasionally people will mirror other people's videos, like Flat Earthers, well, they all mirror the same videos. But occasionally a debunker will mirror another debunker's video with their agreement. He just expected me to post his video. No, Haskins, I don't want my channel full of your crap. I was happy to do a debunk video on yours, and I'm happy to debate. So anyway, after telling me I need to post his video, he then said that he will set up a stream. Well, hold on, I've got a live stream channel. I can do it. If you don't trust me, because you don't know me, have a look at my last stream with Lunacy Lander, who I've actually been emailing with since then. Nice guy. Yes, we disagree on everything, just about, but there's not a problem. But if you find that that's a risk, I'm happy to have a moderator, either one that I could put forward that you could agree to, or one that you put forward that I can agree to, if there is such a person. But no, he's demanding I go onto some other channel. So I asked him, it must have been a total of about 10 times, to email me. Because when you're arranging a stream, you have a lot of back and forth, sort out the time, sort out the rules, sort out the subject, etc. But he still hasn't emailed me. And eventually I said, well, that's it. This is your last chance. If you don't, you can run away with your yellow tail between your legs. He's still running. I've got a bit of a tickly throat tonight. So I might start choking. But I've got my wonderful flask of tea and a pint of the finest water. Yeah, that'll do me. Mail sent to Mr. Sensible. Let's have a quick... Oh, maybe it's gone into... Ah, yeah, it has gone into junk. Let me just have a look. Where's his link? Oh, you sent me the actual photograph, I think. Oh, it says I couldn't open the image file. Try again, but this time just send me a link to wherever it's posted on the internet. I don't know why it wouldn't open. Was it? No, it won't let me download it. Never mind. You could go on my Discord and post it in the general chat, and then people can have a look at it. Try that. It was DJ Moss. Thank you. Thank you. Just flicking over to Flatzoid stream. He's talking. I don't know what he's saying. He's leaning back, talking, scratching his head. Yeah, I guess he'll be in here in a minute. Oh, no, he is there. He's in the waiting room. Da-da-da. Flatzoid, let's get you in here. Okay, I've got Flatzoid in here. He's still muted right now until he actually picks up his mic. And then when he's ready, we'll bring him on the stream. Oh, yes. Looking forward to this. I've not spoken to Zoid for quite a time. As flat earthers go, he might be wrong, but he seems to be like a nice guy. Things are happening. He disconnected. He's reconnected, I think. Not sure, but he's still muted anyway. But hopefully he'll be ready any second. And I'll talk to him about this stuff. Oh, yes. Stuff. I like stuff. H2O rocks. Ah. Hey, greetings, Mr. Zoid. How the devil are you, sir? Are you picking it up through Discord? He says he can't hear me. Oh, sorry, I haven't...
I can come back in and see if that's going to work.
Okay, you try that. Wow. He's dropped out. He's come back in. Let's try again. Hello, hello?
Nope. No sound at all.
What's wrong with that
Sorry
then?
about that. Just no sound. I have no idea what the hell is going on.
Well, everyone can hear you.
Let's see if I can set my settings.
Right, let me drop out. And I'll come back in. Can you hear me now? Hello? Hello, hello? Oh dear. Well, I don't know what's happened there. Flips and Tech, yes! Elko, correct. Yeah, I know you can hear him. But he apparently can't hear me. I don't know why. My mic is on. Don't know. Yeah, because as I'm talking, I'm lighting up. Well, this will be an interesting debate, won't it? Oh dear. Let me just let him know that we can hear him.
Nope.
Hello,
still don't
hello,
hear you
hello.
at all.
I can hear you.
Do you think it's possible that you can rather send me a link to... Well, can it only work on Discord? I don't know.
What do you mean?
Let's see. Maybe my settings have changed on Discord itself. Voice settings.
Has he got deafen on? Oh dear, oh dear. Yes, I just popped onto his channel and let him know. Does my sound need a container? Oh no. Oh, half of his streams has him screwing up something. Oh dear. Well listen, to be fair to Zoid, it's a hell of a lot of bits and pieces you got to get right. Hello, can you hear me now, Zoid? Hello? Speak to me. Dora.
There we,
Shh.
there
Hello?
we go.
Ah, you can hear
I
me.
got it.
What did you do?
The settings on Discord has changed. I haven't used this for such a long time.
Ah, you stopped messing around with it. Did you know it works?
I'm always using element.
Right, anyway, good evening, Zoid.
It's good to have you here.
And it's good to speak to you. It's been a little while, hasn't it?
Yeah.
A little while. Oh, sorry, just to say, Cygnus TSP says that I've got the loudest keyboard ever. Yeah, I've got a nice mechanical keyboard. It's the way to go.
Wow,
Lovely
look
to
at
type
the
on.
bulk
Yeah.
of that thing.
Yeah. So yeah. How are you? How's the family and how's Flirdom treating you?
Yeah, it's going good. Just very busy. You know how it goes.
Well, I've seen you've been doing a lot and lots and lots and lots of streams.
Yeah, I practically have a stream every night. I just take Tuesdays off, so
Tuesdays.
I'm used. That's about it when I do have off.
Yeah.
Yeah.
But are you off this Tuesday, or did you have something lined up? I thought tomorrow. Or was that Wednesday?
Usually I'm off on like tomorrow because Michael usually streams tomorrow, but he can't stream, so I might maybe do a little short stream tomorrow. We'll see. It depends how I feel.
Okay. Well, I did want to talk to you, as you know. It's actually about a couple of things, but the first one was the one which I mentioned to you and you posted as part of your description of the video, was this whole thing of Dell and his upward accelerating Earth. Now, I don't know what your position is on that, so that's why I wanted to talk to you. So it might be that we 100% agree about it. So I just wondered, can you explain what it is?
Not accelerating.
Sorry, not accelerating.
He says it is. I'm saying it's not.
Okay, well, I'll have to violently agree with you then. Well, there's a first.
So it's not much of a debate then.
Well, perhaps you can just tell us, where is he coming from? Because I have heard this on the old Flat Earth Society sort of bulletin board forums. That was one of their theories, was UA, universal acceleration. Everything's accelerating up for some unexplained reason.
Yeah, it's actually based on globe rhetoric, the equivalence principle from general relativity. That's what it's based on. So it is actually globe rhetoric pushed, just with a flat disk.
Well, can you... now, I know that this is not something you believe. You've made that clear, and that's fine. But can you just explain a little bit about what it is he believes, to your understanding?
Well, he can't really make up his mind on what he believes, but he definitely believes it's accelerating. He claims the reason we have pressure gradients is because if he takes a water bottle and accelerates in a car, it displaces to give the densities of the mediums more denser to the back because of acceleration.
Yes, the same as with helium balloons in the car going forward, but other balloons going back.
Yeah. So he correlates that and say, let's turn it vertical, and that's why it's Earth accelerating upwards, which gives our density gradients. And then he...
I mean, that would be, you know, if you had Earth as a disk of some sort that was accelerating up at 9.8 meters per second, that would give you the same effect as gravity. So you would... now, I know you're going to dispute the thing about density disequilibrium, but yes. So if it's accelerating, not just travelling at a velocity, but accelerating at 9.8 meters per second, then we wouldn't, you know, sat in this chair would feel exactly the same. Jumping and then landing on the ground would feel exactly the same. Falling off a cliff would feel exactly the same. Unfortunately, go on.
His argument is, though, the reason relative density disequilibrium doesn't work is because when in free fall with a water bottle, whatever, the density tower, it doesn't separate.
Right. Sorry, I'm just adjusting your sound volume because I've just been told you're a bit quiet. Yeah, go on, carry on.
They said you're very loud. I'll adjust yours as well.
Okay.
Okay, but anyway, they claim when they drop a bottle with density tower in free fall, then it doesn't mix, so therefore relative density doesn't work. You know the old...
Yes, on the vomit comment and whatnot.
Yeah, but when we try and explain it, they all accelerate at the same rate. He doesn't buy that. He doesn't understand how inertia works. He thinks everything should still, even at free fall, still show the density properties, which is false, because if something is accelerating at the same rate, one's not going to have more force than the other. You would agree with that?
I would agree with that. I mean, when that bottle is in free fall, if it's one of those density towers with different liquids, there's no reason, if you gave it a shake, there's no reason for it to sort itself back out until you finish that free fall.
Exactly.
In which case, gravity will have its effect and cause the different layers to sort again.
No, but you see, that's what I'm saying. It's not with me. It's not gravity. With you guys, it's gravity. But simple physics does dictate that it does accelerate at the same rate. I mean, this is measured, observed. I mean, you would agree with that. But with Dell, he claims no, the things don't fall at free fall. He's claiming the Earth is rising up to meet it, so it's decelerating. So if we drop a bowling ball, the bowling ball's not falling. We're rising up to meet the bowling ball. So we don't see things fall. We don't observe things fall.
I know that there's... I've forgotten who it was. Was it Neil deGrasse Tyson? No, it wasn't Neil deGrasse Tyson. It was one of the others was sort of saying that the object is not falling. It's the
Veritasium.
No. No, I can't remember who it was.
Brian Cox.
Whether it might be. I think that was Brian Cox who said that. Mm-hmm. I've actually got a brilliant video, not mine, which explains with a bendy, stretchy graph. It's hard for me just to explain just like this, but a bendy, stretchy graph which shows as an object is moving forward in space and time, or space-time, when you're near a great mass like Earth, which bends space-time, even though it's travelling in a straight line, it will appear to, in the case of a bowling ball, to drop. But it's hard to explain, and I can't really argue.
It's equivalence principle. Right, it's just equivalence principle. That's all it is.
But there's a massive problem with his whole upward acceleration anyway, because whether Earth was created eventually following a big bang and there was some sort of energy imparted in it then, or whether God said go on upwards, whatever it is, that's a constant velocity. Whatever the speed is, every second later it's got to go 9.8 meters per second faster. So something would have to be applying more and more and more energy.
Yeah, but he's trying to explain it as you. Let's take. I call it swing ball Earth. You know when you take if you play swing ball before. So it's practically just a bucket of water, you could say, where the centrifugal force is forcing the force outwards to the bottom of the Earth, and that's what gives the constant acceleration, because you're changing vectors constantly. Yeah,
there's no such thing as centrifugal force. It would be centripetal force. If you're travelling in a
centripetal force is inwards. Centrifugal force is outwards.
But it isn't an actual force. If I was
it's a fictitious force, yeah.
Yes. I'm travelling forward at great speed. If I'm yanked to the side, it will feel as though I'm being pushed the other way. I'm not. I'm being pulled off my course.
Exactly. Yeah. But that's the thing. So he wants to. His argument is moving causes moving. So you know.
South African does Scottish.
You're just retarded, you know.
I don't know how to explain it. So not only do you have to have an increasing amount of force applied, it wouldn't take too long before we approach the speed of light, and we can't go beyond that. Also, if that was the case, why aren't we getting close to the moon and the stars that are above us? Unless they're also accelerating away, which actually then means you need even more force.
And what are they accelerating into? That's also
and where from? Yes.
Yeah.
So basically, his whole universe is shifting. Well, that way.
From where to where, with what energy, what caused energy, we don't know.
Well, look at this. Look at this. Mr. S and Flatzoid agree. Dell's
weird.
Dell's wrong. Dell's wrong.
It's weird.
But you see, sorry, go on, carry on.
But I'll say it's really weird, because I did try and explain it to him, but he just doesn't want to accept actual measurable physics. So it's really bad. I mean, even if he wants to have his centrifugal force, he requires a physical force to have that centrifugal force present.
Hold on,
Because you need.
forgetting the whole thing about whether centrifugal force is a force or not, because I know a lot of people can't sort of get that. But okay, let's go with centrifugal force. What is Earth spinning around?
I have no idea. It's probably tethered somewhere on the North Pole, I guess.
bloody big string.
So will you guys have gravity to hold you guys to the greater attract than the sun? I don't have a clue what he's holding because he doesn't claim gravity. So pixie dust?
I don't know. It's strange. I've had a super chat, Zoid. It is a polite one. It's from Second Best Bob. Just super chatted £10. Thank you, Second Best Bob. Can I please ask Flatzoid why I'm blocked from his channel? I'm always polite there, and I've even sent him super chats. Shrug. I don't know if you know.
I didn't even notice. Probably one of my mods must have blocked him. I will go and check out Mr. Bob.
Well, thank you for the super chat, Bob, and there you go. Zoid's going to check that out. Yeah. So, I picked up on this whole thing with Dell because I know that Rachie has been talking about it as well. Is it that she accepts what he's saying?
Agrees.
Or she agrees with him, does she?
He says constant, she says accelerating. So they agree it's both moving, but she's at a constant where he's an acceleration. That's
hold on. Which way round? Rachie said...
Rachie's acceleration, Rachie.
Okay. So 9.8 meters per second. Per second, going faster and faster. Yeah.
And Dal is a constant.
Well, she's right. In order for it to work, it would have to be per second. Because it's like when you go in a car. If you suddenly put your foot down, you get pushed back into seat. You reach whatever the speed is you're going to drive at, then you're not pushed back any further. It's the acceleration that makes you feel pushed back or pushed down if the Earth was accelerating upwards. So she would be right that it would have to be accelerating. If it was a constant speed, for the first second, you've got 9.8 meters per second down. But the next second, if it's still at 9.8 meters per second, you're no longer accelerating. There's no reason to be forced downwards anymore. So he's wrong big time, basically.
But the problem is, this is based on globe rhetoric, though, because your globe claims the same principle.
Go on, explain that.
Equivalence principle.
Well, it's equivalent. Yeah, it's the whole thing. Like if you're in an elevator, do you know if you're going up and down, or is the elevator going up and down? If you're in a sealed box, that was it. A sealed box on a rocket, like an elevator. The rocket goes up at 9.8 meters per second, you will be able to stand and walk around. But you don't know, is it that you're being pulled down, or is it the rocket and the floor that's going up? They are equivalent. You would not, if you had no windows, you can't see any surroundings, you'd have no way to tell.
Yeah, but that's what I want to ask then. Okay. So on your globe then, every way is going, so the floor's pushing up on you, on your globe. Based on
it's
the equivalence
But
principle.
the Earth's not getting bigger. It's a globe. It's a globe.
Well, that's what I'm saying.
So someone in Australia...
How does one explain that?
Yeah.
So that's what I'm asking. How would someone explain that, though?
I guess that's all the bendy space-time, the curvature of space-time. But like I said, I have a brilliant video. I will send it to you, Zoid.
That'll be great.
It's a... Actually, unless... No, it's probably about 5 or 6 minutes long. Basically, this guy has a graph, and you can imagine he sort of puts a picture of an apple there, and you can imagine.
I know who you're talking about.
So it travels along a straight line.
He's the asylum guy.
I have no idea. I can't remember the guy's name.
He's a bald guy.
I have no idea. But then he bends the graph basically, and so it looks as though.
It's going straight.
It's still travelling straight, but when he draws another line, when you unbend the graph, it looks as if the thing is falling. So I think that's where we're coming from with that.
And then,
sorry, go on.
But then I'd like you to go watch a channel called Dialect. I think his name is Dialect. I'll send the link for you as well.
Okay.
Where he explains the metric tenses and how space and time are explained, and showing that asylum guy is actually wrong in the way he explains it. And
Well, I'm
there's
not.
a few
I'm
channels
not a
that explain it
physicist
better.
or a theoretical physicist, but this bendy graph is probably quite a childish way of thinking about it. But it enables you to really picture.
Yeah, because he puts an
what
X and a
the theory
Y.
is.
He puts an X and a Y.
Yes,
So
but
he's putting the
he's
time-
actually got a
time and the-
winder. He winds this winder, and the whole graph bends and stretches
Yeah.
as an equivalent to the curvature in space time. So the apple that you're letting go of still exists through space time, but it's even though it's going straight, it's following a curved path, as in it's going down. But
you want,
I
we
will
can
send
always-
you. I will send you the video.
Awesome, yeah.
Because it's
If you
it's
want,
really
we
interesting.
can always debate space and time, though. Because we don't agree on that, though.
Well, we're not going to, I guess. Not going to. So do you not think that space-time bends?
No, because it's concepts.
Well, you'll have
Just
to argue the
It's
toss with that,
It's a mathematical concept, though. It's
which you
definitely
can
not physical.
photograph.
You can't photograph mathematical concepts.
Well, that's why it's not just a mathematical concept. It's a physical thing. You can. Sir Arthur Eddington had his famous experiment where he photographed stars near the disk where the sun would be during a total eclipse, and they were out of position because the light had been bent by.
It wasn't an experiment.
Well, it was an
And it's
observation.
correlation.
It was an observation.
So
Einstein.
it's not an experiment then.
It's an observation. It's a fact.
Yeah, but then
it
it's
was
not
pro-
then it's not an experiment then, because you
No.
first have to observe the natural phenomena, then you have to have your
Okay.
hypothesis, and you
Okay,
have to
well,
manipulate
right.
the variable.
Let's stop there. So first, you have to. What was your first one? You said.
Observe natural phenomena.
Right.
So
Okay. So we know what that field of stars looks like. We've got endless photographs of that field of stars. Each star is in a certain placement. So that's our natural position. What was your second step?
create a hypothesis based on the natural
and
hypothesis.
Einstein did.
Yeah.
Einstein hypothesized that the mass of the sun would be able to curve space-time so that the light from stars passing nearby the disk of the sun would be bent, so the stars are out of position. So that was his hypothesis.
But he did that hypothesis before the observed phenomena, correct?
Well, no, he always knew where the stars were. It didn't matter which stars. He would say, if you had, hold on, if you have a field of stars, okay, we know where those star points are, right? They'll move, but they never move in relation to each other, not visibly anyway. And his hypothesis was, if you put a large mass in between the stars and you, then some of those stars' positions would then move. That was his hypothesis.
No, but like I'm saying, you've skipped the first step. He first made his hypothesis, which is a prediction, and then observed the phenomena, which is backwards. You first observe the natural phenomena, then you make your hypothesis, and then I also want to ask, how did he manipulate his independent variable?
Right. Let me just go through this again, right? He hypothesized that light passing near a massive object would be bent, okay? The sun is a massive object, so if you have a time, you can't see stars next to the sun because it's too bloody bright. So the only time you'd be able to see it is during a total solar eclipse, when the stars appear as well, but you've got the disk, the black disk where the moon's covering the sun. So if his hypothesis was correct, light gets bent, stars the stars that are close to that sun would be out of position. They would be bent by the mass of the sun. Their light would be bent by the mass of the sun. Sir Arthur Eddington realised that at a certain date and time there would be a total solar eclipse. So he travelled to the location. You know the pattern of stars that as they exist. Let's say, just for the sake of argument, I have no idea which sort of stars it was, but let's say it was Orion. Okay, and you knew that the sun was be eclipsed as it passes close to the belt of Orion. We all know what the constellation Orion looks like, with the 3 stars in the belt. So anyway, you have the solar eclipse, out come the stars, and the belt, the spacing's wrong. So it was hypothesized and it was tested. The hypothesis holds true. Now, it's possible there's some other explanation. That's
So
why
it's
science
not
doesn't.
scientific. So we can
No,
say
no,
it's
that
not
is science.
scientific.
No, that is science.
Did he-
But you have
has
to
he
come up with another
manipulated-
explanation for it.
He didn't. No, that's correlation.
What do you mean? If I
That's just correlation. If I mean, you can get people. Let's say Nostradamus. He made predictions. Was that scientific?
No, he pulled stuff out of his ass.
Yeah. So just like that, you can do correlation-based predictions. Doesn't make it scientific. You have to actually go and manipulate the independent variable to know that's the cause.
Yeah.
What's
you do?
The cause for light bending? What's the cause for the light bending?
Hold on. You said about manipulating the independent variable. You look at those stars over there that are so far apart. They are still that part. So they're still the correct distance apart. You look at the ones that are just passing by the disk of the sun, being eclipsed. Suddenly, they're not far apart. Not the right distance apart. Sun goes on. The next night, you look at those same stars. They're back to their correct position. Their light has been moved.
Yeah, but
so that was a prediction.
What's the cause for that?
The curvature of space-time caused by the mass of the sun, and it's not just that though, because he also predicted that light from far galaxies and light from far distances could be bent around galaxies, and there is such thing as an Einstein cross, where you can see a quasar and it appears 4 times as a cross because its light is being bent both sides around the mass of a galaxy. You can see those photographs.
Would you be able to give me the hypothesis for this? What the cause, what the IV was in DV? Because it seems to have multiple causes.
No, it has one cause that we are aware of. Okay, we've always got to be careful. Einstein had his theory that supermassive objects would bend space-time, and so the light paths would be bent. That was his theory. Okay, until we were able to find any evidence of it, that's all it was. Sorry, his hypothesis, beg your pardon. Until we were able to find evidence that supported it, that's all it was. So Arthur Eddington photographed that, and the stars were out of position by the predicted amount. So that means his hypothesis so far is good. It could still be...
Anybody else?
Yes.
Sorry, has anybody else managed to get the same result as Eddington?
Well, I couldn't name them, but it's been done more than once. But also there is... let me find you a photo of an Einstein cross. I've got one here.
Because like I said, so the cause for bending space-time, well, the cause for light bending is space-time bending. And the cause for space-time bending is mass.
Yes, mass causes it to bend. I'm just trying to get this photograph.
Okay, so let me get this right. Mass causes nothing to bend, and a concept created by man for a reference to bend. To show
hold on, say that again. Say that again.
Space is just availability. That's what space is.
It's available ability.
Availability, that's space. You would agree?
There's an Einstein cross. So I'm not sure. This is in Pegasus. It's a quasar that appears 4 times because its light is past this galaxy in the middle, and so you get 4 paths of light from the same object being bent by the supermass.
It's just not separate light, though? How do you know it's just not separate light, though?
What, separate objects, you mean?
Yeah.
Well, I mean, you get an object emitting light. The light shines in all directions, doesn't it?
Mm-hmm.
Yeah, if I had a round globular light, switched it on, it lights up in every direction. But there's an object in the way. Now, some of that light is passing to the left of it and is curved towards you. Some of it's passing to the right and is curved towards you. So you're seeing it, the same object, from more than one direction.
But light travels in straight lines, though. If it's
yes,
away,
and it does travel in
curve towards you.
No, it is traveling in a straight line. It's traveling in a geodesic. The problem is that the substance of the universe is bent. And here, if you didn't like that one because it's. But
that's the thing. The universe isn't substance. It's free space. It's available space.
the fabric of the universe, whatever that fabric
What,
is.
what fabric?
That's in the widest
There's
sense.
nothing
of the
there.
term. It's
That's what I'm
dim-
saying. 10 to the minus 17 tall is hardly anything. It's available space.
No, we're not
It's
talking
not
about
physical.
10 to the negative 17 torr is hardly anything, but that's just a number of atoms. That's not what we're talking about. We're talking about dimensions getting warped.
Yeah,
But
dimension of free space, of available space. So in other words, that availability you're saying is physical.
here you go. There's an Einstein ring. That is one galaxy that's the light of which has been bent as it passes the central object. So that's not multiple objects. That is an object, a galaxy.
How do you
whose
know
light
it's just
is-
not refracted there?
Well, it's basically bent by the mass.
Diffraction. Yeah, but what about diffraction?
Hold on.
What
If
if
it's, hold on. If it's diffraction, what's it diffracting through?
Exactly. That's what I'm saying. It's
Yeah,
not
so
my
it's not
claim,
diffraction.
though.
The light.
You guys are making the claim that it's just you making a claim that it's scientifically validated, correct? That this is a scientific experiment when they took this photo.
Well, that's not.
Correct.
That's just an astronomical photo. There are many astronomical photos of Einstein rings and Einstein crosses.
And would you say what he postulated to be is fact that it's that?
Sorry, say that again.
And you would say if he postulated that's the reason for that ring, that's fact that that is the reason for the ring. In other
Well,
words,
he
he's
predicted.
proven then that's that.
He
That's what
predicted that if his ideas were correct, then if you had a galactic-sized mass, then further objects would have their light bent. That was a prediction from his idea, his hypothesis, and then we found it. So it's always possible, Zoid. This is the whole thing about science not proving. It's always possible that there's some other explanation or something else in conjunction with his explanation.
That's
that
pseudoscience. That's
No.
pseudoscience. That's,
No,
that's
hold on. What do you-
science.
Go on.
You see, the thing is, science is like we say, an empirical method. It will prove the effect, and it will never change. So if I take heat and I use heat to cause to boil water, it will always cause water to boil, no matter if I do it tomorrow, today, or yesterday, or if someone else does it. Heat will always cause water to boil. You would agree? If you put enough thermal energy into water, it will boil.
If you put enough in, yes. But
Great, so
as we know, atmospheric pressure or the pressure the water is under will affect that. So if your theory was, if I apply heat, this water will boil at 100 degrees, you test it, it boils at 100 degrees. Unfortunately, you then find that if you go up a mountain, it boils. It takes a much higher temperature for it to boil. So
Less
you weren't
temperature.
wrong. You weren't wrong.
It takes
but
less
you,
temperature to boil. In a vacuum, it
Yes,
takes
yes,
less
yes.
temperature.
Yeah, beg your pardon. You're right. Quite right. And pressure pressure cooks the other way. But the point is, you weren't wrong, but you needed to expand your theory. So your theory saying if I apply this much, it will boil at 100 is correct. But
No.
then if you change the pressure, you will need a different amount to get it to boil.
No,
so
but
you weren't
that's-
wrong,
that's-
but you refined your
that's-
your
Yeah,
theory.
that comes with systematic experimentation after your hypothesis. So once I've already got my hypothesis, heat causes water to boil. I've validated that. Then it comes systematic experimentation. How much heat do I require to boil? Do I need less water? What kind of container do I need? How much heat do I need? That comes with systematic experimentation.
And so
But that
so
doesn't,
with
that doesn't invalidate that heat causes water to boil. Now you can have a control at how much atmospheres, you can say, causes it to boil. But do you think putting water in a vacuum causes water to boil, or is it just degassing?
well, you're not at absolute zero, so there is some heat there.
But you do understand if you put water in a, let's say we just
If you
stuck
take
water in a
if you
vacuum
take the air
chamber.
pressure, yes, that's right. You take the pressure right down, it will boil away.
No, degassing is not boiling.
Well,
There's a big difference between degassing and boiling. With boiling,
But you're sort of
the water
getting
goes...
away from this thing with the Sir Arthur Eddington, because
No,
those
I'm giving
stars.
you a point on science because you're
Oh, are
claiming
you?
Sir Arthur Eddington is science,
Yes,
and I'm trying to show you it's not scientific because there's no manipulation of the IV, so it's just correlation based.
but there is. If you look at those stars a little later on, a few hours later, because the sun's gone, the eclipse has finished, the sun's gone, the stars come out, you will find that the position of those stars has changed back to what they normally are. So during the eclipse, when the light was passing close to the sun, the light from the stars was bent, and you cannot deny that. There's a photograph. There are photographs.
Then I can do exactly the same and make a prediction. God sticks a magnifying lens when there's a solar eclipse around the sun's corona, and therefore the lights are out of position. I've taken a photograph and proved it. I've taken a photograph.
So you're saying that it's refracted.
Yeah, God put a magnifying in front of the sun's corona, therefore the lights were out of place.
Okay, well there's another theory then. So we got Einstein's theory and we got God's bloody great magnifying glass. Okay, that's fine. But listen, that would be absolutely fine to postulate that as a possible explanation. There are lots of possible explanations. Then you have to try and rule them out.
Okay, but there's a photo showing this now.
A photo? What? Showing what? Showing the magnifying glass or just showing the result?
Showing the result.
Showing the result, yeah. So then you'd have to think, well, hold on. Einstein said it's because it's close to the sun. Flatzoid said it's because it's a big magnifying glass refracting the light. So how else could we test it? That's science.
So how did you test then Einstein's predictive theory?
Well, because of the same theory, you've got things like this... Einstein's ring and the Einstein cross
which I said God stuck a magnifying glass in front. That's why we get it.
I mean, just saying God did it isn't very scientific now, is it?
And just saying space-time did it isn't very scientific either.
No, but
that's why what I'm trying to explain to you. To go through science is an empirical method. You have to manipulate the IV to know the cause. If you don't manipulate the IV, it's not scientific. It's pseudoscience because you're just correlating based on the belief.
Well, no, because we can see that galaxy here in this ring has had its light bent. You look at another galaxy, a similar sort of distance away, that does not have a supermassive object in the way, its light isn't bent. There's your IV. So if it has...
No, that's not IV.
Of course
it's a different location. You're looking at a different location. If you say you're looking at a different galaxy,
yes,
correct?
Yes.
How is that changing the IV?
Because light travelling a certain distance appears as a galaxy shape. A light travelling the same distance but with a massive object in the way gets distorted.
I think you're missing my point altogether there.
No, I don't think I am. I think we're getting into the whole IV-DV thing.
Yeah, because that's what science is. It's a method. You have to manipulate the independent variable so you know it's the cause. Just like heat causes water to boil, you can test that straight through. It's empirical. It's proven that heat will always cause water to boil.
I have manipulated the IV with whatever that star was, Sir Arthur Eddington was looking at. As I said, let's say it was Orion, just for the sake of argument. I could take endless photos of it, night after night after night. The pattern of the stars will always be identical. Okay? I get the solar eclipse passing just in the right place, close to it. It gets distorted. That's my independent variable. My independent variable is hold on. My independent variable is when I took a photograph of Orion.
No, that's false. You observed the natural phenomena. When you looked in the sky, you saw the light bending, correct? Now you want the cause for that light bending. So that means you have to presume a cause for the light bending, which you would say is space-time bending, correct?
Well, we'd say it's a supermassive object in the way, or a massive object in the way.
Okay, so how did you manipulate your IV, your independent variable, to validate that of being the cause for what you're observing?
Because I looked at it when the object was there and when the object wasn't there. When the object was there, it was bent. When the object was not there, it was not bent.
So magnifying glass then can be validated?
Well, magnifying glass, your God glass, could be another explanation, but isn't it funny that this God God magnifying glass is only there at the same time as the eclipsed sun.
Yeah, weird, eh? Almost maybe like it's magnetized to the sun or something. But that's what
I got a feeling you're just pulling
possible.
South African shit out of your ass.
But I have to make it as ridiculous as possible to show that it's not an experiment. That anybody can just use correlation and say you see it's science when it's not science. That's what pseudoscience.
Right. I mean, we're going to go round in circles, but from my point of view, to recap, Einstein had an idea. He had a hypothesis. He made a prediction. Someone went out and tested that prediction and found that prediction was fulfilled. There may be another explanation, but his prediction has been tested in many ways, including predicting things like Einstein rings and crosses. They have been found. Now, it's always the possibility is another explanation, but it's going to have to fit the available evidence more closely than Einstein's theory.
Okay, I got a super chat for you though.
Yeah, please.
Looking is not manipulating, dummy.
Well, you got your jug of water and you apply some heat to it. That's not boiling. You look at it again a bit later. It's boiling. You have manipulated the time that you looked at it. So applying a blowtorch to this will not make it boil instantly. It's going to take a couple minutes or however long. So there's your independent variable. Some time has passed, and I look at it again.
That's false, because even if you looked at it or not looked at it, do you think it would still boil?
Yeah, but you haven't established the fact. If I apply the torch to this, it's not boiling. If I don't look at it again, even if it is boiling, I don't know that it's boiling until I look at it again. Oh, it's boiling now because I left it 5 minutes.
No, it will definitely boil even if you don't look at it.
Does a tree?
The cause is not looking at it's not the cause.
No, and looking at it is not the cause.
It's the heat that causes.
Yes,
it's the heat that causes.
But unless you take that measurement,
looking at it
is the measurement. I am measuring it. Yes, that looks like it's
looking
boiling.
at it is in the experiment. Looking at it is part of the experimentation.
Yes, that's what I'm saying. It's an observation. It's a measurement. A measurement could be taking a temperature, taking a sound reading, looking at something. Has it gone red or whatever the hell it is? Those are all observations as part of the experiment. So our experiment, boiling this water. Yes, we're applying heat. We need to allow some time, and we need to actually check it every now and then. It's not boiling. It's still not boiling. Oh, it looks a bit hotter. Now it's boiling.
Okay, so let's say you didn't add any heat to it, and you looked at it, and you walked away, you come back, you look again, and it didn't boil again. What did you manipulate?
Sorry, if I haven't applied any heat, I look at it, go away, come back, look at it, and it's still not boiling. Is that what you're saying?
Yeah.
So you asked me what have I manipulated? I haven't manipulated anything.
Great. So looking at it's not a manipulation. It's just an observation based on experimentation. The cause would be the heat.
Yeah, I've taken 2 observations, but unless you make the observations, you're not going to see if any manipulation has had any effect or not.
Great, but you still had to manipulate the cause. Hence, if I had heat, it boiled. If I had no heat, it did not boil. So what was the cause for that observation to take place?
What? Sorry, the observation that the water is now boiling.
Yeah.
Well, our theory, our hypothesis is that it's the heat.
Yeah,
and that's
exactly. So you manipulate the heat. So that's why let's put it back to editing thing then. What was the manipulated cause for that observed phenomena?
The location of the sun.
So location of the sun is cause. How did you manipulate the location of the sun?
By checking the pattern of the stars the night before, during the eclipse, and the night after. So they were in position A the night before. During the eclipse, they were at position B. After the eclipse, they were back at position A.
So correlation, not cause. Then, like I said, you didn't manipulate anything. You just
but you could
at
say
a different time.
You just claiming correlation. Well, you're saying that water's boiling because I'm applying heat, but how do you know? That's just correlation. It is a correlation. It is a correlation.
It's causation.
Yes, but
I can prove it's causation because I can give it heat, and it happens every time I add heat.
Yep, well, I can prove that it's the mass bending the light, because every time you look at a solar eclipse, if the star's in the right positions, you can see that they move.
Yeah, you're seeing it. You didn't manipulate it.
Of course you manipulate it.
You didn't manipulate anything.
Yes.
You just looked. You observed. That's all you did.
All right, so you don't actually have to physically wiggle. Was it Riley's going on about wiggling the independent
You
variable?
physically have to manipulate
No, you
something
don't
to
have
know
to
it's the cause. You do.
Of course you don't.
Yes, you do. How do you know it's the cause if you don't manipulate it?
Do apples rot if you leave them on the side for 6 months? Yeah. But
Yeah,
you don't
entropy.
do anything to make them rot. You apply time. You go back every day and look at it. Okay, you take your measurements, and then after 6 months you find it's a collapsed mass of stinking rotten fruit.
Entropy, yeah.
Yes,
Now, let's
but
say
the point
let's
is,
take that
you
apple-
haven't
let's
had
take
to
that-
physically do anything. You don't have to physically do something. Often you do, but you don't have to.
You've just observed the natural phenomena with the apple rotting after 6 months. Okay. Now you want to figure out what's the cause for the rotting of the apple. Okay? It's the breakdown of the enzymes, let's say, would be the cause. Now you go and you manipulate that. Would you, let's say, go and freeze the apple for 6 months? Would it still be rotten?
Yes, you could try. That's what you would do. You would try to rule it out. Is it because it's just in room temperature? Hey, let's stick it in a very low temperature freezer for 6 months. See if the same happens. That's a manipulation. Yes, you could.
Great.
Look at,
So then you would
could
know.
look
Then
at
you would
other-
know if it's caused or not.
Yeah, but I mean, you just said it's entropy. It's stuff basically deteriorating, collapsing, falling apart.
Yeah.
Yep.
Yeah.
So we look at another apple, leave that one 6 months. That one does the same. And then look at another apple. We've looked at 100 apples. All of them, after 6 months, have collapsed and rotted away. Okay, so you have made lots of observations. So your prediction that if I leave an apple out in 6 months' time, it will be mush. Well, we've tried it 100 times, or however many apples we've done. It's always held true. Not once has that apple not rotted, apart from the time we kept it in the freezer.
Yeah, but like I was saying, so this is where systematic experimentation comes in. Let's take 4 different apples. The one you're going to freeze, the one you're going to stick in a humid place, the one you're going to stick in the sun, and the one you're just going to stick in a very dry place. And then after the 6 months, you come and observe what has changed between the 6 apples. What have we manipulated through all those different experimentations? The environment. Correct? So the environment at play towards the apple is what we manipulated. So we would be able to know, this is what caused the enzymes to break down, and that's why we have the rotting apple. Scientific. I can validate this because if I go and do it tomorrow again, I know I will get exactly the same result because I know what caused the breakdown of the enzymes.
So if I can jump in then, if it's a total solar eclipse tomorrow, if I look at that total solar eclipse, I know that stars that are very close to the disk of where the sun is being eclipsed will be out of position. That's just another.
but that's just observing.
I've looked at 100 solar eclipses, and every time stars. Yes, but you're observing the apples. You're not doing anything with them. You're just putting them on the side. I'm not doing anything with the eclipsed sun. I'm just looking at it. I'm looking at the apples. I've looked at 100 solar eclipses. Always, that stars that are very close by get shifted out of position. I looked at 100 apples. Always, after 6 months, they've rotten if they're just left out. There's no difference.
There's a big difference because I physically went and manipulated the environment the apples were in. You just went and looked at the stars and said, I just observe again, therefore I believe it's this, so therefore it is. I got another super chat that explains it to you.
Okay, and then I've got some as well.
Says,
Go ahead,
okay.
you go first.
They say they are taking unproven theories, treating them as fact, and then building on top of them, not science.
So again, taking.
You're taking unproven theories.
Uh-huh.
So in other words, looking at the sky.
Well, there's no proof. It's a
treating
theory.
them-
Yeah.
Treating them as fact and then building
There
on
is
top
fact.
of them.
There is
That's
fact.
not science.
Right. There is
What's the
fact.
fact?
The fact is that star's light was out of position. Whatever the cause, that star was moved. That's a fact.
Whatever the cause, so you
Yeah,
don't know the cause,
yeah.
then
Whatever the
that's not
cause.
science.
Yep. I mean, if Einstein hadn't come up with any explanation, someone just decided to take that photograph, and they knew the astronomical positions, and hold on, that star's out of position. That's a fact. It appeared on the photograph out of position. Einstein had an explanation. More than that, he didn't just look at the photograph and says, "Oh, I know why that's happened." He had predicted beforehand that it would happen, which makes it a lot more powerful.
Okay, like I said,
more super chats to read?
How about Nostradamus? And just quickly, Nostradamus also had predictions that came true. Okay, he predicted
Well,
it. So was it proven because he predicted it?
Nostradamus came up with all sorts of vague and poetic claims that people see, like, for instance, I just say, Zoid, I don't want to get into the whole 9/11 thing, but for instance,
But
people then said, look, Nostradamus predicted it, but no one said beforehand, look at that prediction, that means that those towers are going down. No one did. They fitted it afterwards. That's no good. You need a prediction that enables you to, right, he's predicting that perhaps this day, this week, or this month, this is going to happen. So we can have a look, see if it, does it happen? Does it happen? No, it hasn't happened. It's no good looking at it and saying afterwards, he told us that was going to happen. Well, you're just fitting it in. And even if he was right, it was totally useless prediction because no one identified what it was predicting beforehand. Do you have any more super chats to read? Because I've got a couple as well.
Oh, no, you can go.
Okay. This is from David Molinaro. Thank you, David, for super chat for $10. Space-time can be explained like this. If I say, meet me at 5 p.m., your question would be where? That's space. If I say, meet me at the town square, your question would be when? That's time. Mm-hmm. Yeah, but that's... what I'd have to say, though, Dave, that's not space-time. Space-time, all one word, is a bit different.
But that's based on the metric tensors. Yeah, he's more or less right in very rudimentary terms.
But he's also super chatted $5 Australian, so it's Australian and US dollars, I think he's super chatted. Oh, no, beg your pardon, it's someone else. Someone called My Perspective. Hey, Keith, unblock me too. You're always saying everyone is welcome. Someone called My
People like to be
Perspective.
blocked. I'll check him out as well.
Okay. Oh, my goodness. Oh, he super chatted again. The same thing. Unblock me too, please, Keith. I seem to have got 2 super chats from you, my Perspective, saying the same thing. Very kind. Perhaps Flatzoid will unblock you twice.
I'll block him. I'll unblock him, block him, and unblock him again. How's that?
I've got a message from someone called Nike or Nikki Spitz. Oh, Nikkei. I see you they super chatted me the other night and I didn't get the pronunciation. Nikkei. Sorry, Nikkei. Why do you stream the same time as Toon? Well, if Toon had said to me, hey, I'm streaming tonight at a certain time, I might have said, you know what, I'll wait a couple of hours, or the other way round. But we can't keep up with everyone who's streaming. I mean, you must have the same thing, Zoid, that you're streaming. I think someone said QE is streaming as well. I don't know if he is.
But he's streaming, I think, now.
Yeah, so you're going to get
in an hour.
You're going to get clashes, I'm afraid. So what I'd say, Nikkei, is watch both. Watch this one and then Toon, or the other way round.
Download the one, listen to the other tomorrow.
Yeah. And the last super chat in the queue is from 3Ron for $5. It's so cute. Flatzoid thinks he knows the scientific method. Time is absolutely a variable. This is demonstrably.
Ooh.
Or I guess demonstrably so.
We can debate that as well. Please manipulate the independent variables as time for me, please.
Well, time. Let me think of an example. Well, actually, just a really simple one is if I took that apple before it's gone mouldy, I let go of it, it doesn't fall. Not for that fraction of a second. I'll give it a couple of seconds and it's down on the floor. You have to allow time. You're boiling water. You apply heat, as I said. It's not going to instantly boil.
So sorry,
you have to apply time.
Sorry, so time was the cause for the water to boil, and time was the
No,
cause for the apple to fall.
it's an independent variable.
No, it's pseudoscience is independent variable. It's not. It's a control. So that's what I'm saying. Manipulate time for me, please. What does time cause?
Time allows other things to happen. If
So
you're
it's a
kicking
control
the,
then. If it allows
no.
other things to happen, it's a control. It's not an independent variable. It doesn't cause things. Time does not cause anything. It has to be an independent variable. It has to be a cause.
It's an independent It's an independent variable. I mean, if you want to Google it, you'll find that time is an independent variable.
Pseudoscience, yeah.
Oh,
Pseudoscience,
so all the references on the internet then that say time is an independent variable, they're all pseudoscience.
Pseudoscience, yes. Usually based on psychology and
A
genealogy
subtle
and
blend
stuff,
of
yeah.
extreme violence and psychology. Well,
Okay, no, but like I'm asking, if you prove to me now that you can use time to cause something. You can't, exactly.
No, I
Can't
used
cause
time.
anything.
I used time. I deliberately didn't say anything. I used time, and you spoke.
You didn't cause me to speak.
Well, we would still be sat here in silence.
What
No, I didn't cause you to
caused the
speak.
voice-
I allowed time. I
Yeah.
allowed time, and then
So it wasn't
suddenly
time. Time wasn't the cause then.
it's a variable. It's not.
Yeah, a
it's-
control variable, not
It's
an
a
independent
variable.
variable.
It is a variable. It's independent in that I allow some time to pass and something happens. If I don't allow that time to pass, it hasn't happened. Applying the heat.
How do you stop time? How do
You don't
stop
have to
time then?
stop it. Why do you have to stop it?
Because you just said if I allow time to pass.
Oh, okay. Oh, I
that's
see what you
time
get.
stop-
Okay, right. So if I I'm applying my heat to my glass of water or whatever it is, kettle of water, if I only allow 30 seconds and then measure it, it's only got up to 30 degrees. It doesn't boil.
Heat was
But if-
still the cause for that water to get hot, was it not?
Yeah, but you said heat would cause
Wasn't
it to...
time.
No, hold on. You said heat would cause it to boil, yeah?
It does.
Yeah, but I measured it after 30 seconds and it was not boiling. Therefore, heat
Time was
has
the
not...
control.
Sorry?
You gave a control of 30 seconds. That's what time was. You controlled it
Yeah,
at 30
but-
seconds.
but,
The duration of time was 30 seconds, so therefore it's a control, not a independent variable.
But it is independent. If I took temperature measurements every 10 seconds or whatever, I will get a new temperature reading. And eventually, after, say, 5 minutes or whatever it is, that's boiling. But
Great. So we
if-
can do
if-
the same now without heat. Will the temperature change if you don't apply any heat?
Well, we
do the same- we do
we'll leave
exactly the same.
we'll leave aside the whole business about going up mountains or whatever. But so we're in the same place. Okay, I've got a second glass of water. I don't apply heat. Every 10 seconds, I take the temperature, and it's the same. It's the same. It's the same.
So not time causing.
I didn't say
Anything
time. Time causes. Time is an independent variable. As in, if you allow a variable amount of time, different things can happen, which would
Do you
not
know what a
happen if you
control-
didn't allow that time to happen.
Would you be able to explain to us what a control variable is?
Right, hold on. I've got a super chat from 3Ron again. Thank you. Beg your pardon. They've got two super chats. From my perspective again, his name is Aaron Armstrong, the guy who...
Aaron Armstrong, okay.
Okay. I mean, I no idea whether you blocked him or not, or whether one of your mods did, whether it was a valid blocking or not, but I'm just passing on the super chat. And I've got a super chat from 3Ron, excuse me, saying, put heat to water for 30 seconds, not boiling. Heat for 10 minutes, now boiling. Time is absolutely a variable. The amount of time is the independent variable.
No, the amount of time is the control. Hence, you've proven my point when you said don't add heat to it. It won't boil no matter how long you wait. If you don't add the heat, there's no boiling. You can wait for eternity. It's not going to boil the water. The cause for water boiling is heat. The time it takes to boil is a control variable.
You said you can wait for eternity, it won't boil. Mm-hmm. You've just
Because they
applied...
evaporate.
Well, okay, we'll stop. But what I was going to
But
say was, assuming no evaporation, you're going to have to actually wait for an eternity to find out if you're correct. It may, 10 minutes before eternity, suddenly boil without heat. Why? I don't know. But you see, this is it. You've got to rule things out. So in fact, just going back a bit. So your idea of applying the heat, causing it to boil, and yeah, we find that happens, that you apply a certain amount of heat for a certain amount of time and it's boiling or whatever. But unless we actually waited an eternity, we don't know 100% for sure whether a few minutes before eternity it would suddenly boil. You cannot rule that out. I think it's damn unlikely.
You do know eternity is just a concept.
Okay, 1,000 years. Okay, so, but do you see what I'm saying? That this is why science doesn't prove. You could do 1,000 tests with that, and every time you applied a certain amount of heat for a certain amount of time, a certain amount of heat for a certain amount of time, it boils. Okay, so your idea looks good, and so far we haven't seen anything to rule out your idea being correct. But we haven't tried certain other things, like waiting 1,000 years or trying it up the top of a mountain or whatever it is.
Okay, I also got 2 super chats for you, and then I'm going to quickly answer you quickly there. Television, he says, speed up time, please.
Why do I need to speed up time?
Because you say it's an independent variable.
No, I'm allowing a different amount of time to pass before I take my measurements.
So it's not an independent variable, it's control then. And then another one from Awesome Lawson Clips. He says, how many IVs in a hypothesis?
You can have more than one independent variable, but then things start to get tricky, don't they? Because which is the variable that's causing it? Because it could be a conjunction of 2 variables. In fact, with our boiling water, there are 2 variables. It's the atmospheric pressure and it's the amount of heat you're applying. So X amount of heat at ground level is will have a different effect on that water than X amount of heat at a different pressure. Or what if you kept the same pressure, but do you see what I mean? You're balancing 2 things then.
No.
Those are 2 independent variables that you have to account for.
Explain. No, there's one independent variable. The pressure would be a control. The pressure would be a control. The heat is the independent variable.
What? Why are you saying the heat is independent?
That's why it comes with systematic experimentation.
Yeah, I'm not going to disagree with you. I'm just asking you to explain, why is the heat an independent variable?
Heat causes water to boil. Thermal energy. This is proven. Thermodynamics. Everything you use today is based on this thermodynamic principle. It's a proven fact. Heat will always cause water to boil. Now, if you change the pressure to make it boil at a lower temperature, heat still caused it to boil. The pressure was just the control.
But let's say it's now boiling at 80 degrees or whatever. Why is it boiling? Is it boiling because you've applied heat, or is it boiling? Yes. Yeah, okay. But I could have the same amount of if I've got the amount of heat to boil it at this lower pressure. If I allow the pressure to rise, it will no longer boil. So my independent variable then is the pressure. Do you see what I mean? You can have more. No, the pressure is the control.
The pressure is the control.
You just picked one and said this one's the control, that one's independent. But they're both. You could have both. You could have the same, applying the same amount of heat and adjust the pressure, or the same pressure and adjust the amount of heat.
But you had heat. Now just change the
pressure. But you had pressure.
Heat. Okay, remember I asked in the beginning, does not adding heat and sticking in water in a vacuum chamber boil the water?
Well, what I would say with that is it's commonly regarded as boiling away.
But it's not boiling.
No, hold on. You just asked me a question. It's commonly regarded as boiling away. What I would say, because I'm going to be open and honest, is technically I don't know if that actually is boiling or if it is just, as you say, degassing. So I'm not going to argue the toss over that, okay? Because I don't know.
I can tell you it's not, though.
Well, you tell me it's not. That's fine. I've not looked into that. Whether you would say if you reduce the pressure in a vacuum chamber, this suddenly starts bubbling and then slowly disappears. Is that boiling or is it degassing?
I can explain the differences if you want.
Well, please do, because
interested.
commonly it's known as it boils away in a vacuum. Why are you laughing?
With I'm trying to think how I can explain to you. With the boiling, with the heat temperature, it creates a phase change. You get water vapor, the steam. Okay, so it turns to water vapor. Correct, because of the heat energy transference.
Yes.
Now, when you degas something in a vacuum chamber, there's no water vapor. The gas is simply escaping the water to fill the available space. It's not water vapor. It doesn't go through phase change. The gas is simply escaping the water. There's no heat involved with that.
Well, there is heat unless you take it down to absolute zero. Is it boiling at a much, much lower temperature?
There's always temperatures.
Well, unless you're at absolute zero, there is temperature. Yes.
No, there's always temperature. Even
no, not at absolute zero. There isn't. By definition, there is no temperature.
It's zero, absolute, but you can't get absolute even by definition of physics. It's impossible to get naturally.
Well, you wouldn't be able to measure it, because as soon as you try to measure it, you would be in some form applying some sort of heat. But absolute zero means that all the atoms and molecules are absolutely rigid. They are not moving.
And you can't get that. It's impossible. Yeah, we know. But like the point is...
So therefore there is always heat. So therefore, we've already established you apply heat, you go to a lower pressure, then it will, up a mountain, that water will boil at a lower...
Doesn't boil. It degasses. The gas is
escaping. So why is it boiling at ground pressure? Atmospheric, 1 atmosphere. You call that boiling, but up there it's not boiling.
When you add heat, it boils. If you don't add heat, it doesn't boil. Remember, the pressure only causes the temperature to be less at boiling point, so it lowers the boiling point. That's what the pressure, because you've got less pushing against the liquids and the gases.
I've just spotted. It's not a super chat. Just spotted a comment. I want to give the guy's name. From Justin Franks, says degassing is when dissolved gases are expelled. Water in zero pressure is boiling. As I said, I'm not going to argue the toss over
that. So dissolved gases is now water vapor.
No.
And I've got a super chat as well for you. Sensible thinks the ISS is traveling at 17,500 miles an hour.
Well, there's a change.
A bit off topic, but...
it is off topic, but I'll quickly address it. Yes, it is. And I did a video that showed the predicted path of the ISS, and I went out and filmed it with my phone. Yeah. So it's there.
But like I said, with degassing, it's not boiling.
Well,
it's simply the gases evacuating the liquid, where boiling is it's going through phase change, and that's what's happening. But it's two different things.
The point, so here I am at ground level, roughly sea level. So you're saying if I apply a certain amount of heat to that water, it will boil, yes?
Always have to apply heat.
Okay. Yes, I'm applying heat and it's boiling. Good. So if I go up to the top of Everest with my glass of water and I apply heat, will it boil?
Yes, because you lowered the pressure, so the temperature needed to get it to boil is just lower.
Okay, so instead of boiling at 100, it's boiling at, say, 90 or whatever the hell it would be, yeah?
Yeah, okay. Yeah.
So I go up higher and apply heat, and it's now boiling at 70. I go higher and apply heat, it's boiling at 60, and so on, until I reach a height where the amount of heat I need to apply is virtually nil. I'm still applying a tiny bit, perhaps the warmth from my hand, and it's boiling because the atmospheric pressure there is so low. So we agree now. Okay. So now I go up higher still. I don't apply any heat. It boils. So
there's always heat present. There's always heat present, Mr. Sensible.
Okay.
Gases
so I already said
heat.
to you.
Liquid
I said
moving
to you.
as heat.
Yes, but so I applied 100 degrees centigrade worth of heat to this glass at ground level. At Everest, I applied less to get it to boil because of the lower pressure. I go higher, I apply less and less and less and less until I reach the point that just the warmth of the water itself, it will boil. So
Yeah,
basically,
but
like
does
an
it-
atmospheric pressure gradient, we've got a boiling water versus atmospheric pressure gradient.
So the
a
heat
vacuum
is still
chamber
the
is
cause
boiling
then.
it.
So the heat is still the cause for boiling, not the pressure then.
Yeah, but you don't have to apply the heat. Just taking
Heat is
down
always
the,
present.
yes, heat is
Yeah,
present, but that's
pressure's not the independent variable. Pressure didn't cause it to boil. Heat caused it to boil.
Did it? So that's not boiling. I take down the pressure, it boils.
Pressure just brings down the temperature it needs to boil at. Okay.
Well, there's not gonna be much left, see.
And this is also you assuming that there's gonna be water vapor at that temperature, at that altitude.
Well, that's what you were saying, but I mean, basically, we have two variables. We have the amount of heat applied, and we have the pressure, and you're juggling one against the other. A little bit of heat and very low pressure, it will boil, or a lot more heat in a higher pressure, it will boil. Two independent variables. So
Okay, and then
I can't boil that at 90 degrees down here. So if I change the pressure, my independent variable, I am now boiling it at 90 degrees because I've reduced the pressure.
Great. I just want to say thank you. Got a super chat quickly from Skeptic. Thank you for your channel support. It just says channel support. And then Retro Bull, he says, Gerund went glurf. So it's only fair Mr. S goes flurf.
Sorry, say that again.
Gerund went glurf. So it's only fair Mr. S goes flurf.
Jaren. I said I wanted to speak to you about a couple of things. We started off with Dell. Jaren is indeed the other one I want to talk to you about because there's been a bit of a conflab between the two of you, hasn't there? So what's your argument about with Jaren? With my mate Jaren? Tell me, what's he done? He's not my mate.
Jaren, the guy fighting for geometric horizons.
Right, come tell us what the issue is. What's he said?
I can show my latest video quickly if you want to. That explains it quite easy.
Well, why don't you drop me a link? I'll happily pop the link into the chat. But just
okay. But let me just explain it to you.
Yeah,
anyway,
please.
The argument he gives is exactly what you guys Globers give. The geometric horizon is physical. Okay.
Right.
So he's claiming horizons aren't optical. That's globe based, correct?
No, there is. You're taking one thing and also turning it into another. You have a physical horizon. What you see is the optical horizon. It could be a bit further or even a bit closer than the geometric horizon. Hello? Oh. Hello? You dropped out there for some reason. You back?
I pressed the wrong button by
That's okay. Sorry, I was just... Yeah, I did hear your question. I did reply, but you might not have heard it. I said you're taking one thing and sort of applying it in a different way. You've got the geometric horizon. If you have a ball, then looking at that ball, there is a physical horizon, okay? A point beyond which, a straight line from your eye to the top of the ball. But what we actually see, because we're looking at that through several miles of atmosphere and you have refraction, you see something slightly different, the optical horizon. It may be a bit further or not quite as far as the geometric horizon, usually a little bit further.
Yeah, but that's what I'm saying. He's fighting for the globe with the geometric horizon, so that makes him not a flat earther, correct?
So, well, what's
that's just one of the things.
I've not heard.
One of the
Yeah, but
arguments.
I've not heard what he said. So, what has he said? He said there's a geometric horizon. What
Yes,
about it?
And he says you can't debunk it. And he
Right.
says science doesn't prove things. And you know what his argument is for why science doesn't prove things?
What's his argument for why science doesn't prove things?
Rocks cause waterfalls.
Oh, do you know, I did see some comment about that in some of your video, and I didn't look into it. I've no idea what that's about. But the thing with the horizon, I'm presuming that the whole thing with that is because of sextants. Is that why?
Sextants, yeah.
Yeah.
He doesn't
I
know how
thought so.
sextant works. Remember when he went on McToons and he said, yeah, you can use the curved adjacent to get an angular reading.
Right. Now,
But throwing away what an angle is.
No. What I tell you what, just in the broadest layman's terms, what is an angle, Zoid? How would you just...
Two straight lines meeting at a vertex.
Yep, spot on. I'd agree with that. I mean, there's different ways of saying it, but I agreed with that. Yeah. So why is there a problem? We have a sextant here, and it's measuring an angle, in this case, between the sun and the horizon, yes?
Yeah, and the horizon, exactly. So he's physically pointing at the horizon, correct?
He is pointing, so the light rays from the horizon pass through the horizon mirror at B and through the scope to his eye, and at the same time we've got the light from the sun coming off the index mirror, bouncing off the horizon mirror through the scope, and he moves the arm backwards and forwards until he gets them to align properly and takes his reading. That gives you an angle. That gives you an angle, doesn't it?
So he points the sextant at the horizon.
Yep.
He seeks where the sun is, and he brings it down to the horizon.
Yep.
And then he swings it left to right to make sure it's
as low as possible. Yes. Yeah. Okay. So we got an angle, haven't we? So we got an angle.
Angles in succession to the horizon.
In succession.
Yeah, that's what the principle. The sextant principle is based on angles of succession. In other words, A and B have to be parallel to one another to give an angular reading.
Well, yeah, because light reflects with the same, is it the same instance angle? So if it hits that mirror at 45 degrees, it'll bounce off at 45 degrees, doesn't it? That's how a mirror works. If you're stood dead in front of the mirror, the light reflects 180 degrees back to you, doesn't it? If you stood looking at an angle at 45 degrees to a mirror, you'll see off at 45 degrees, won't you? So yes, you're right. You need to adjust that mirror so that the path of light from the sun bounces off A, bounces off B, so it goes directly down the scope, doesn't it? Because you made the adjustments. Yeah. Okay. So that's fine. So what we end up with is an angle between the view he gets through the scope of the horizon and the view up to the sun. That's his angle. That's his angle. Yeah.
Yeah.
So why is that a problem?
You just explained it can only work flat Earth.
No, I haven't.
That horizon, would you agree he's physically pointing at the horizon, correct?
He is pointing at the horizon, yes. Is he at the same level as the horizon?
Straight.
Hold on. Is he at the same level as the horizon? In this diagram he is, but he could be stood on the top of a mountain. In which case...
That's why you have height of eye correction, so you can be more accurate.
Exactly. So if he was that, as in this diagram, an absolute straight line from his eye through the scope, through the mirror to the horizon, then that's simple. That gives you the elevation angle straight off. If he's at the top of a mountain, you have to allow for that height, don't you? Because that's extra. That would make the angle too big, because you'd be looking slightly down to the horizon, up to the sun, so your angle's too big. So you correct it back, don't you? You adjust for the height.
Okay, I'm gonna ask you a question. No matter your elevation, altitude, are you looking straight out to the horizon when using a sextant, because it has to stand parallel?
No, it doesn't have to stay parallel. You could use a sextant.
You don't point the sextant downwards.
Well, if you
point it straight ahead of you. That's the point.
Hold on. You point the sextant at... Well, you're pointing at two
90
things.
90 degrees.
No,
90 degrees.
Hold on. Let me answer. You point the sextant at the two things that you want to measure the angle between. They could be horizontal. There's no reason it's not horizontal. If, as I was saying, in this case, we're using it in the standard way, holding the sextant vertically, looking straight through it, you're looking at the horizon. Okay, if your eye, you're sat there in the water, so that your eye level is through the surface of the water, basically, then you don't make a height adjustment, do you? If you're at the top of a mountain, by definition, you're high. You're looking down towards the horizon. That horizon has gone a bit further, but you're looking down to the horizon. You adjust for the height. You even said you adjust for the height.
When you go onto a mountain and you look out, do you look down to the horizon, or does the horizon rise relative to eye level?
It doesn't. That you can see further. Yes. So
the horizon looks higher. The horizon looks higher.
It looks higher, but
mountain.
it's still downwards. Why do you make a height correction? Why do you make a height correction then?
Because the sextant, to be more accurate, requires the sextant to be on the same plane as the horizon.
No, it has to be horizontal.
Exactly, same
No,
plane
no, horizontal.
as the horizon.
No, horizontal doesn't mean that. If I could be stood at the beach, okay, looking horizontally forward, and the horizon is, to all intents and purposes, horizontal to me. If I'm in an aeroplane and I look straight forward, I'm not looking at that same horizon. I have another horizontal. It's just it's parallel, isn't it? It's another horizontal. If you have yes, what does horizontal mean? If I hold a spirit level, do I have to hold it down on the sea level? Or could I climb to the top? No, I could climb to the top of the building and I've got a new horizontal. It's parallel to the ground level one.
Sorry, I have to laugh about this. You do know you're literally fighting for flat Earth here. I don't even have to do anything.
No, what I'm saying is, because you're saying you have to, you can't take a reading unless the Earth is flat. I'm saying, let's just say, for the sake of argument, that the Earth was flat. Okay, if I go to the building and I use a sextant, I'm not at the same level. I've taken a new horizontal parallel to that lower horizontal.
So it's parallel to horizontal then?
It's another horizontal. Every horizontal stood at this point is going to be parallel, isn't it? But the point I'm making is, if you don't even need to see the horizon, you don't need to, all you need is a horizontal, don't you? Or a vertical.
You can create an artificial horizon because of the sextant principle. Like I said,
You mean one of these?
You don't have that. If you don't have that horizontal baseline,
I don't need a
not going to
horizontal.
work.
This is an artificial horizon. It's
which gives you a horizontal reference.
Hold on, no, it doesn't. That's not how you do it.
Yes, it does.
Right, there's an I'll show you then. Shall I? Can I show you?
Go ahead.
Okay, so there's, for anyone who hasn't seen one, there's an artificial horizon. You put a liquid in it, and then you've got a couple of filters to because the reflection can be very bright, basically. There's one in use. So you're looking down, and you can see the filters make, I think he's looking at the sun by the looks of it. It could be a spotlight, though. Dim it so you can actually see it. Yeah. Okay. This is a guy using an artificial horizon. In this case, a plate with some molasses on. There is a horizontal through the molasses. We have two beams of light coming. Listen, I presume it's the sun. So we got a beam of light that's hitting the molasses and a beam of light that's coming down straight to the sextant, which is the normal way you would see the sun in the sextant. So he has not got a horizon to look at, not a real horizon. So what he actually does, instead of bringing the sun down to the horizon, he brings the sun down to the reflection in the molasses. Now that means we've already established that the angle of incidence where that ray of light hits the molasses is the same angle it bounces up. Okay, so where we reach the sextant, you've got the same angle from the sun, the same angle there is twice. So basically, you take the reading, you bring the sun down, so it's reflected. It matches the reflection in the molasses, and then half that angle, and that's your angle of elevation. No horizontal whatsoever, no horizon even seen. You do not need a horizon.
You just literally said, look at that horizon baseline for the artificial horizon.
No, what you aren't right. His sextant, one mirror is pointing up at the sun. Yes, the direct view. The other mirror, or looking through the other mirror, is not through a horizon. It's looking down, literally, to the artificial horizon.
Mm-hmm. And he's making them parallel to a horizontal.
No, what he's doing is he takes the measurement. What's the angle? Just as with our first example, this one, just as you're taking an angle between the sun and the horizon, in this one, he's taking an angle between the sun and not looking horizontal out from his sextant, but he's looking downwards to the reflection. But that gives you twice the angle. So in effect, that there's a fictitious horizontal where those two lines meet. So where your direct view comes just to the left of the 2 times HS, because he's got double the angle. So whereas, let's say in this one, you read it and you get the height of the sun as 25 degrees, in this one he's looking at the same sun, the same time of day, he gets height of 50 degrees, but then he halves it, gives him 25 degrees. Boom.
Yeah,
no horizon
exactly.
used.
Because he set a horizontal. That's why he
What
made
horizontal
an
is he?
artificial horizon. The molasses is a horizontal.
It's lower than him, Flatzoid. He's had to adjust for height, hasn't he? He's adjusted by halving the angle.
Exactly, to get to the horizontal.
Hello, can you English? Look, so in this case, he's had to, in effect, he's taken a reading that's twice the size, so he deducts half the reading. Yes. In this case, the horizon is slightly down, so you deduct because of your height, and it also, I was going to say Coriolis, I don't mean that, I mean refraction. It's the same thing, but you don't need to have a flat surface. Where is his flat surface there?
He's standing on a flat surface, the ground.
What does it matter? Okay.
The molasses is on a box which is flat. It's showing a horizontal baseline for that molasses. That molasses is literally standing level.
Yes, but it's not a flat Earth between here and the GP of the sun, is it? It's a little dish with a flat surface that he's just using as a mirror.
Remember when I told you how a sextant principle works? Angles in succession. You're literally showing angles in succession here. Why do you think he needs to halve it?
He's halving it because he is making the correction for the fact that his artificial horizon is way below the horizontal.
Yeah,
so where
exactly.
Yes.
So
I don't know why you're laughing.
Angles in succession.
Because in this case, you adjust for the fact. So you don't halve this one, but just for the sake of argument, let's say measures that sun as 25 degrees above the horizon. Oh, but the horizon is 1 degree down, so that's actually 24 degrees elevation. That they use the horizon because it's pretty damn close to horizontal from your eye line, pretty damn close. But you have to make corrections. This is nowhere near close, but it's a very simple correction. You just half it.
Because the
How about that then?
Succession.
How about that then?
There we go.
A bubble sextant. No horizon used at all. You establish a vertical.
Sorry, what does a bubble do? It's a level, correct?
A bubble. In fact, there's no. Okay, to be level, what does it have to be? You can say it has to be flat and level.
Would it be showing that you can make it horizontal, correct?
What
the
you've
vertical
got
and the horizontal is perpendicular.
Do
That's
you know
what the bubble level is doing?
I'm not being rude because I mean I don't know whether you would know and don't know whether you would be expected to know. But do you know what is inside that bit where it says the bubble chamber? Where I'm sort of wiggling my mouse.
Guessing liquid and a bubble.
There is liquid in a bubble, but basically you've got a slightly curved top to the container that liquid is in with crosshairs. So obviously, if you're tilted one way or another, the bubble won't align with the crosshairs. So in this case,
it's the same kind of that you have on a theodolite. So you can.
Okay, I'll bow to your superior intellect on that one because I don't know about theodolites. So anyway, there is actually a light source in there, so that you can see the bubble. The image of the bubble reflects off a mirror, back up to the beam splitter and through the scope to your eye. The sunlight, much as in the ordinary sextant, reflects off the index mirror, off the horizon mirror, and you're not even looking at the horizon, and then straight through the telescope. So instead of establishing a horizontal and an angle above it, you're establishing a vertical and an angle from it. So you do not have to see a physical horizon. You're not using an artificial horizon, and it doesn't matter a damn if there's a mountain in front of you or a valley, or whether the Earth is flat or curved. It would make no odds. You don't need it. The shape of the Earth you're standing on is not going to affect that reading.
So when you use the bubble level and you're making it perpendicular to vertical, that would mean
Not
you're
perpendicular. You're
looking
making it
horizontal.
vertical. You're making it vertical.
Yes. So
Okay.
when you look through the scope is perpendicular to that vertical, correct?
Yes. You're
A
basically
horizontal then.
so you've established your vertical by making sure the bubble is properly aligned, which means the sextant is being held. The bottom yellow line that goes left to right, that path of light is horizontal. You did not need to look at horizon to establish that. You did not need to bounce it off molasses. You have established that as a horizontal from the vertical, i.e. perpendicular to it, 90 degrees from it. So tell me
Right.
why then? So if that red line coming down, that's your 90 degrees vertical, isn't it? That's to your zenith, obviously.
Mm-hmm.
The ray of light coming from the sun, you're measuring the angle between those two. So where they meet, so you've got red down and the yellow coming across, and let's say, just for sake of argument, that's 50 degrees off of that vertical. You haven't had to. You haven't. It doesn't matter what you stood on. You know that
Yeah, it
wouldn't.
doesn't matter what you stand on because your reference is horizontal.
It doesn't matter. Yeah, it doesn't. Yeah, yes, it doesn't matter what you stand on. So why the hell do flat earthers then, Zoid, say you got to have a flat Earth because you can't get an angle from a curved adjacent? I'm not using the surface of the Earth at all.
Okay.
I'm not using the horizon. I'm not using the sea. Nothing. I'm just using
Okay.
a bubble. Sorry,
when you
I'm getting
take-
overexcited there. Go on, carry on.
When you take the star's GP,
Yep.
it's on the same elevation plane, correct?
What do you mean?
So when you take a measurement to the star's GP, you need
No,
to
I don't take a
do your
measurement to the
height
star.
eye correction.
No, okay. I don't take a measurement to the star's GP. I'm using a sextant to find out the angle between that ray of light and vertical. With a bubble sextant, I've got a vertical. With an ordinary sextant, I've got a horizontal. So I can deduct the angle from 90 to give me the angle between vertical and the star. So
Yeah.
let's say that that's coming in 30 degrees above horizontal. Therefore, that star is 60 degrees off of my zenith. That's
Great,
all
so-
I know. 60 degrees off my zenith.
Great. So when you measure 60 degrees off of zenith, you've taken your 90, you've minus the 60 degrees. and
No,
you've
minus the
got your-
30 to give me the 60.
Okay.
Yeah.
So that
yeah.
you're saying co-altitude angle.
Yes.
So you've used your co-altitude angle now to get the distance from the GP of the star to you.
Wherever that star is. I don't know off the top of my head. I need to look it up in the almanac.
Great. Okay, so let's say you've worked it out now and it's 3,600 nautical miles away,
Okay.
or whatever.
Yep.
That GP from that star has to be on the same line of reference, horizontal, to where the observer is.
Why?
For the 90 degrees to work out, because you're
Why?
creating a triangle.
No, I'm not. No, I'm not. You've already, right at the beginning, we agreed on what an angle is. It's two rays with meeting at a vertex.
That 90 you are starting off with, that's the GP of the star's 90, correct?
No. What I'm doing... well, actually... No, I have my zenith. It's whatever is directly above me.
You standing 90 as well, yeah?
Well, I'm stood up.
At 90 degrees.
Yes, to the 90 degrees to the floor. Aren't I?
Right. And the GP of the star is also 90 degrees to the floor in its
Yes.
position.
But why does that have to be the same? Let me just try. I don't know. I thought about this earlier, Zoid. Okay, right. If I'm looking at you, okay, you're the star, and I'm laying on my back, and you're absolutely overhead. You're at my zenith, yeah. Mm-hmm. Okay. I then turn, let's say, 45 degrees. Oh, you're not at my zenith anymore, but you're still here, aren't you? So if I
I'm
roll
still
my
at
eye,
your zenith.
Yeah,
I'm
no.
still at your zenith because I'm ahead of you. You're just looking another direction.
I'm looking at another direction. Yeah, my zenith, because I'm round a curve, is different now because I have moved around. I now measure the angle and I find, oh, it's 45 degrees to where Flatzoid is directly above, to where I am. Therefore, I now know that I am 1/8 of the way turned around. If I carry it, if I do another one, I'm now quarter of the way round. you're now 90 degrees off of my zenith, aren't you? Quarter of a circle. That's all we established. All we're establishing with a sextant is how far I've turned. In this case, how far round a circle I've travelled. We know how big the circle is. We know how big the circle is. Therefore, if I know I've travelled quarter of the way around a circle, if the circle is 10 metres, I have travelled 2.5 metres. Boom. That's all you're doing.
Do you think I can quickly share my screen?
I'm quite happy for you two, but let's see if we.
I just want to draw something on Paint quickly for you. That's all.
Right, I'll have to try and screen capture it. Let me just try and get this set up. It might be a bit of jiggery pokery here, because I'm gonna have to try and capture it on.
I also don't think we can go on too long. It's already almost 1 a.m. here. I've got work in a few hours.
Do you know? Yes, yeah. Oh dear.
Sucks that we had to start so late.
Yes, I mean that's true, but I think Flatzoid. One thing I do need to say.
You know, I'm just going to quickly draw it on my, and then I'll just send it to you. Then you can show it. How's that? I'm going to draw it.
Oh dear. Mm-hmm. Right. So you're sending me something, are you?
I'm going to quickly draw it, then I'll send it to you.
Oh, okay. And I can post the image. That's easy enough. Yeah. Yeah. So I mean, the basic principle behind all the celestial navigation stuff with a sextant is you're finding how far the star is off of your zenith, how many degrees. So, okay, we can't see through the Earth, but imagine that the Earth was translucent. If you could see the star was now directly below your feet, you know it's the other side of the world. You've travelled, or your distance from that star's GP is 180 degrees, half the way around the world. Then it's converted to a distance. That's it. I don't know how you're sending me. Are you emailing it me or what?
I just almost finished drawing it, and I'll take a... Because I'm doing it on Paint quickly.
Okay, that's fine. Are you going to DM it to me then?
Yeah, I'll DM it to you quickly.
Well, while Zoid's doing that, let's just... Oh, my screens are jumping around all over the place here. Where are we? Just wanted to check a few bits. How many people we got in here? And I hope you're all enjoying this. I've been enjoying it. I got a bit overexcited earlier on. Because it's frustrating for a Zoid. I mean, this whole thing, it's a Nathan Oakley thing. Saying, oh, you can't take an angle from a curved adjacent. I'm not using a single curve. I'm using a tray of molasses or a bubble sextant or looking at a horizon which is slightly dropped and correcting back up to a horizontal. It doesn't matter what's between you and the GP of the object. It could be valleys, it could be seas, it could be mountains, it could be, an eighth of the way round the world or whatever. It doesn't matter. Because wherever that star is, it's still got its own GP. It's over another point on the Earth.
Okay,
that's what's in the almanac. We look that up and we know, because we've calculated, we're 600 nautical miles from wherever that GP is. Look it up, this date and time, there's the location, we're 600 nautical miles from there. Which doesn't tell us anything other than we're in a circle around it. Yeah, go on. You've got it.
I've sent it to you.
Okay, let me just pick this up.
This is exactly the same problem Jaron had.
I've seen your diagram. This will be interesting. I will let you explain it, and then I shall respond. Okay. Let's see if I can pay. Is it going to let me? Oh, let me save it first. Hold on. We'll be there in just a tick.
I haven't used Discord in such a long time.
Well, that's good. I was able to drag and drop it off of Discord. I didn't know I could do that. Right, so there's your image. Let me just zoom it a bit. Oh, if I look at the right window.
Great, okay.
Okay, go on, you go.
So on the left, that's what you guys are assuming, okay?
No, it
the
isn't.
one on the left that's closer to you, okay? The horizontal line would be that red horizontal.
Well, that's okay. So just so we get where we agree and don't agree, that red line is a horizontal on both of them.
Yeah.
Okay. I'm going to
Now,
zoom it
when
in a
you-
bit more just so people can see it. Go on.
Okay.
There we go.
So when you're standing at that 90 degree, that
Here,
would be that
this cross.
vertical, yeah?
Yep. Okay.
You're looking up and you're measuring an angle to the star. Correct?
Okay. So I could be using the yellow line upwards, bubble sextant, and measuring down, or I could be looking at the horizon or a tray of
No, you're
molasses.
standing using a nautical sextant at the moment.
Okay.
You're standing on
Okay.
that red
Okay.
line on the,
Okay. Yeah. I'm using, okay. In
and
this
you're
case,
looking out at the horizon.
looking
okay?
out at the horizon, and yes, we measure an angle up, make corrections, and then deduct
So you
it
measure-
from 90 to get
so you-
that one.
Great. So you're measuring the angle to the star. So you would agree
Yeah, yeah.
that adjacent and the hypotenuse is two straight lines.
It's not an adjacent and a hypotenuse. It's
Yes, it
it's,
is.
No, hold on. It's
You're
the red,
making a triangle.
Right. No, hold on a second. We're stood at that cross point, yeah?
Mm-hmm.
Yeah. So we got one ray going to the star,
Hypotenuse, yeah.
one ray going that way,
The adjacent, yeah.
and there's our vertex. That's it.
Yeah.
That's two rays
Sorry,
and a vertex.
the star has a GP on the ground, correct?
Yeah, well, for a start, it's not there. The star's GP would be somewhere
Exactly.
around
That's why I look. That's why I look to the right.
there. Yes, like that. So that's how the star's GP would be, yes.
Great.
But-
So would that change the angular reading?
No,
Why not?
because the angle in both of those is between the red line and, sorry, I'm a bit colourblind, whatever colour that is between, what colour is that?
It's between white and baby blue.
Okay, so we got the line from the star to the cross, line from the star to the cross. What we're measuring here is the angle between the red and the line from the star to the cross. What we're measuring here is the angle between the red and the star to the cross. The fact that
No, but-
the fact that the star's GP is there or misdrawn there makes no odds. All I'm interested in is that angle. Two lines and a vertex,
course
an
it
angle,
makes a
as we
diff-
established
of
at the
course it
top of the
makes-
show.
Of course, it makes a difference.
Why?
You would agree because the star has to be 90 degrees, correct?
What do you mean?
The star has to be 90 degrees on Earth's surface, just like you are 90 degrees on Earth's surface.
The star is, if you're stood here, it's 90 degrees. If you're stood here, it's not.
Exactly, but I'm saying, let's say you got someone standing underneath the star at 90 degrees. They'll be
Okay,
on the
so
right.
we got someone stood there.
They're looking upwards.
They're
So
looking
the
up,
star's
and that
right
star's
ahead of them.
The star is right over their head. Yes. Okay.
Great. Okay, and then you got the observer standing on the top there,
There. Yes.
also at 90 degrees.
To
Okay.
what? Oh, 90 degrees to the surface of the Earth. Yes.
Yeah.
Yeah.
Okay, so they each got their own different zeniths.
Yep.
So
So
he takes-
so person A has got a zenith that points to the star. Mr. Sensible has got a zenith that points just up there somewhere.
Straight up, yeah.
Yeah.
And you take a measurement now, let's say 45 degrees to that star.
What, me? Here?
Yeah.
Okay, so
Yeah.
so I have used my sextant through all our clever means, and I established that angle there. Yes.
Okay, great. Now
I'm
I want
done.
to ask you, we're minusing the 90 degrees to get the co-altitude angle,
Okay,
correct?
so what angle were we saying? This was 45, was it? So this is 45 as well.
Yeah, but you're taking 90 degrees
Yes.
of the star's GP,
No.
and you're minusing to get the co-altitude angle of the star's
what's
GP.
what's the hold on? What's the co-altitude angle?
The co-altitude angle is the apparent angular measurement. So
Of-
the
of
apparent
what?
angular measurement, the correction of the apparent angle measurement.
No.
So if
no,
you
no,
take,
no, no. Can I
if
correct
I
you?
take 45 degree measurement,
I tell you,
I have to-
let's
I have
can we
to
say
minus
can we
it.
say can we say 40 so we get 40 and 50? We don't get two 45s, just to make it clear as to what we're talking about.
okay.
Okay, so it's
40,
45
you
degrees
measured at
up.
40. You
Yeah,
measured at 40 degrees.
Yep.
Okay. Now you have to take 90 degrees.
Yes, which
Okay.
is yeah.
And minus the 90 degrees by 40,
Yep.
which gives you 50 degrees.
And where's that 50 is there, isn't it?
Yes, co-altitude angle.
Yes. So what?
Okay.
So just to
Listen.
So yeah, but I'll let you carry on. But just to explain. So what I've done is I have used my sextant, measured that the star is 40 degrees of elevation. Therefore, The co-altitude is 50, which is 90 minus the 40, i.e. that star is 50 degrees off of my zenith.
Great. Okay. So, does that star have a 90-degree angle as well?
That star has a GP somewhere.
As in of 90.
Where your matey boy is sat over there.
And it will have the same circle of equal altitude.
What do you mean it'll have the same circle of each?
It has to have the same horizontal plane. You're completing a triangle here.
No, you're not completing a triangle.
Yes, you are. You're doing triangulation. You're doing
no, you're not.
You're doing Sakatoa.
No, we're not. Okay.
Yes, you are.
Okay, if you're doing Sakatoa, what's the height of the star?
You can't get the height of the star because
Why?
it's apparent. Because I've proven this with my
You just
challenge.
said you're solving that triangle with Sakatoa.
I can give you a citation that says you're doing Sakatoa if you want to.
Well, you're not. Okay, let me run you through what.
I can give you a citation that says you're doing Sakatoa.
Okay. Give me a citation.
Okay.
I'll give you a chance to find it. I'll just get my Discord sorted out. Hold on, I've killed Discord. Hold on, if he's still there, give us a second. Well, that is not. Hello, you still there?
I can hear you.
Okay, good. I accidentally killed Discord, so I don't know how I didn't lose you. That's good. Yeah, sorry, you're just getting a citation.
I'm just looking for. It was on my other PC, but I got it on my. I think I got it on one of my videos. Then I can find where I got it. Channel. Just quickly looking where I got it. Because they actually teach people to use using Sakatoa for celestial navigation.
I suspect if you come across a reference to it, it's in a different aspect of it, because you don't solve any. If you solve a triangle, if you've got two angles and a side, or two sides and an angle, whatever, you can solve all the lengths and all the angles. We haven't got that. And anyway, we're not interested in solving a triangle. What we're interested in,
yes, you do.
Like my example, when I was on my spinny chair, all I'm interested in is how far have I turned around. I've turned around, in this case, 50 degrees. Therefore, that star is 50 degrees off of my zenith. Therefore, I know the percentage or the distance around the Earth I've travelled. That gives me a distance. I didn't need to solve any triangles.
Just trying to see what's the name of the. Because they give it everything. They explain it in Sakatoa and everything. I actually showed this to Mactoon before as well, but yeah, just ignore this. There we go.
Oh, you got it, have you?
It's www.staff.vu.edu. Would help if I actually put the link down there, and I didn't.
Yeah, if you pop the link in there, and I'll. Excuse me.
No, I said it would have helped if I did stick the link down there. I just have to look for it. It's been a while.
This diagram with the two circles that you're showing anyway. I'm not referring. Even you have said that one on the left is incorrect, showing that GP of the star coming down at a funny angle to the surface. Why are you even showing that diagram? Because that's not what we're sort of saying anyway.
If you're doing Sakatoa, that's exactly what you're saying.
So is this where you're talking about? You were talking about your circle of equal altitude.
Your circle of equal altitude has to be on the same.
Yeah, no. But is that why you're showing that wider triangle? Because that's not a GP. The GP of the star would be roughly halfway between those two lines.
I'm going to just quickly stick the video until I find it, but it's got the citation there for you. You can actually go through. I'm going to look for the actual citation. I've stuck it to you.
Hold on, I've got the video. What am I looking for? Is it the...
I'm just trying to look for the actual citation quickly, but it's on there. You can go to 32 seconds as well. You'll see it there.
Let me... Right, I think... yes, I've got it up on the screen. So, it's... Oh, 32 seconds in, did you say?
You can go even to 32. It's going to show you Sakatoa. The thing is, this is they use this specifically to teach nautical navigation to students.
Sorry, 32.
I think it's 32. Where was it?
That's trigonometry review. Oh,
there we go.
What, is that the one that you're talking about?
Sakatoa.
Right, so what is this? Because I can't see what that says. It's quite small. Trigonometry, yeah. The three basic trigonometry relations that we're concerned with here are sine, cosine, tangent. They're ratios of length of two sides of a particular triangle. Particular type of triangle is most useful in maths is a right triangle. One angle equal to 90. Where's it saying about this in relation to celestial navigation?
It's a whole document. This is just the one part on Sakatoa. You can go through the whole thing.
But we know what.
I'm just going to look for the whole.
Okay, because we know what Sakatoa is. That's the whole point when flat earthers say you're solving a triangle. Well, why can't you tell me the height of the star then? Because using Sakatoa, you can calculate those sort of things.
No, remember, if you can use Sakatoa to get my height of my floss, then I can say, but you guys can't get that right.
Sorry?
No one has managed to do my floss challenge yet.
I don't know anything about that. I don't know anything about that.
Are you good with trigonometry?
I can muddle my way through it. I'm not going to be able to do stuff.
If I give you the
point is this is solving triangles using sines, cosines, and tangents. You don't do that to get the co-altitude angle. The co-altitude angle tells you how many nautical miles away you are from that star's GP. That's it.
Mm-hmm. How do you get that co-altitude angle?
Well, we just done it, didn't we? We just did it.
Yeah.
Sorry, let me just... No, hold on. Where's your image? There's your image. Okay, so I measured the altitude of the star at 40, which deduct from 90 gives me a co-altitude of 50. It's 50 degrees off my zenith. So it's 50 times 60 nautical miles away to the star's GP. I haven't solved any triangles. I've got the answer.
You do know the 90 degrees you are working with is the star's 90.
What do you mean? I'm stood here.
Mm-hmm.
Okay, I'm stood here. The star is 40 up.
The star is 90 degrees in reality. Otherwise, you wouldn't get
a star
complete. Otherwise, you wouldn't get your complete triangle, would you?
I'm not solving a triangle. I have taken one angle, the measured elevation, and deducted that from another angle, from 90, to find out how far off of 90 it is. So if it's 40 degrees above horizontal, therefore by definition it's 50 degrees off of vertical. Boom, that's it. I haven't solved a triangle. I've done one simple subtraction. That's all I want to know. And now I know that. I know wherever that star's GP is, could be anywhere, because I don't know them off by heart, and it depends on the time of day, but wherever it is, I am now X nautical miles away from it. I'll get my nautical almanac, look it up. Oh, there's the location of it. I'm X miles from it. That's
okay.
I'm
going to ask you again. Remember, I asked you, are you good at trigonometry? So, if you measured 40 degrees to the star, okay,
elevation,
and we know the internal angle. Some of a triangle is 180 degrees. Okay.
Yes.
So we've taken the 90. You've minused your 40, which gives you 50. So that means it would be 50 degrees of the star, correct, in the corner, on the top.
But all we're interested, Zoid, is
listen. That would be 50, correct?
Right.
So there's your co-altitude angle without without minusing.
Do you know? I think I can see where you guys are all going wrong. You're just trying. You've got your first angle, the angle of elevation of the star, as you said, 40. You know that the star is at 90 degrees to the Earth's surface somewhere, and then that gives you the remaining number of degrees. That's what you're talking about, isn't it?
I might have to draw this again because this is simple.
Yeah, it's simple. I don't see why you don't get this. I mean, look, you see your diagram, okay? If that star, because of course I know it's just a drawing, so the star's very close. But if that star, okay, I'm at 12 o'clock. If that star was at 9 o'clock, right over here, okay, I mean, because it's parallel light, it would appear exactly in the horizon, wouldn't it? So when I measured its elevation would be 0. Deduct that from 90, it's at 90 degrees to my perpendicular. Therefore, its GP is a quarter of the way round the world. There, at 9 o'clock.
Okay, I've given you with all the angles in.
Oh, right, you got another diagram. Okay, let's just see if I can get that one in nice and easy. Will it do it that way? No, I'll have to save the darn thing again first. One sec. This one, yeah?
Mm-hmm.
Okay. Yes, that's true. But that's what I'm saying. I see where you guys are going wrong because I'm stood here on the right. I measure the star's angle as 40 degrees. We know that somewhere on the Earth, the star is directly overhead. It's at zenith over its GP.
Which would mean it's
90
50
degrees,
correct?
Yes, which makes 50 there. Yes. And in fact, if you were to draw a line from the star across here horizontally, that would give you a 40 up here. Of course, yeah. So you're
if you had to draw a line from that star now, not showing 90 degrees, would you get the same angular reading?
What do you mean if I had to draw
like we said on that other diagram that you had now previously that I drew? With on the right, that 90 degree wasn't 90 degrees anymore.
This one, yeah,
the one on the right, the other side.
Sorry, this one. Sorry, say it again. Oh, right. So you're saying that 90...
Would that still show 50?
Right.
Would that still show 50 and 90?
Yeah, of course it wouldn't, because... but this is why you guys are going wrong. You have come from the background thinking the Earth is flat. I know that's 40 degrees. You hear of co-altitude angle deducting from 90 and taking it up there. Okay? But if that was the case... If I moved a bit further away, so I don't know how many... If I move further away, so it's no longer at 40 degrees, it's at 30 degrees, okay? The distance between the star's GP and this one won't equate to the equivalent distance between there and where I've moved to. Like...
Yeah, bring up your quick
like
picture
that. This is why it doesn't work, because every
sextant up again.
Hold on, look at my diagram. I know it's going the other way. So we got the sun. Mr. S on the right has the sun at its zenith. Mr. S, the next one, it's 10 degrees off, so it's elevated at 80 degrees instead of 90. It's elevated at 70 degrees, 60 degrees. Okay, 50, 40, 30 degrees, but the distances between them aren't the same. But in actual fact, using celestial navigation with a sextant, every 10 degrees will be 600 nautical miles. This won't work.
You want me to give you what's the linear relationship why it's flat?
Please. I'm all ears.
Bring the picture of your sextant up quickly.
This one?
Yeah. Look at that index arm. Is it curved?
Well, this here? Where the the readings are.
Yeah. Is that curved?
Yes.
Is that an angular reading over an arc?
What we've got is we're measuring an angle. We're six.
Yeah, and is that index arm traveling over an arc?
Well, if you have a rigid object and you turn it around, the end of that object's going to trace an arc, yes. So,
Great. So there's your linear distances. The distances come off of that linear arc.
Right.
You're closing your celestial sphere with the
What?
bottom of that arc.
You're closing your celestial sphere. No.
It's
So-
your angular reading,
okay,
just like the
but-
protractor that you just put on.
Like one of these.
Mm-hmm.
What about it? Sorry. Where is it? My picture I just showed you. That one. Yeah.
Mm-hmm.
Right.
You see the bottom of that protractor, that curve, that arc? You would agree every degree measurement is the same linearly the same distance.
What's some? I see.
On
So between that one and that one, it's the same.
Exactly
as
the
that one.
same.
Yes, but because all that is, that's a rotation, isn't it? You're rotating around
on
the
the arc.
point.
On the arc, correct.
Well-
now that angular measurement is two straight lines
Yep.
meeting at a vertex
Yep.
on a arc, correct?
I'm on the flat Earth, across the bottom.
No. Yes, you on the Earth, but the angular reading is an arc.
Well,
It's an opening
No.
between two
Yeah,
straight
but
lines.
I could draw this the other way, Zoid. Well, in fact, there's lots of Mr. Sensibles there who have taken angular elevation or used a sextant to get the angular elevation of the sun. Now, with celestial navigation, if I am 10 degrees away from zenith, I'm 600 nautical miles. If I'm 20 degrees, I'm 1200 nautical miles, and so on. So why suddenly do these distances get bigger? I'm on a flat Earth, according to you. Okay,
I've explained
so,
it. It's that
but you
arc.
haven't.
You're
Are you-
measuring on
so
the
you're
sextant,
saying
the arc.
are you saying then if each one is 600 nautical miles apart, are you saying that this guy over on the right or this one next to him, when he took his reading, he has misread the height of the sun?
No. Straighten that curve out now of that index arm arc. What happens when you straighten it out? Will that give what you're seeing now on the bottom with that flat, not having the same linear distances anymore? If you had to straighten that curve out.
So if I distorted the image to make the curve
If you took the curve, that arc,
And bent
you
down
made
each side of it.
straight, and you
Yeah.
bent it straight.
what would happen to
Would
the
it
Earth? The
still-
Earth would turn to a sphere or a curve. Yeah.
No,
Well, if I'm
you've now
distorting
made
that
that
image,
arc. You made that arc straight now. Would you still have the same linear distances?
I don't know what on earth you're talking about.
You wouldn't, because the vertex would be at a different location, correct?
The vertex is at the sun.
Yeah, but I'm saying if you're taking the sextant.
with these rays, the vertex is at the sun. For me, starting from right to left, it's 90 degrees. The sun's directly ahead of me. I move a distance away. Oh, the sun appears to have dropped by 10 degrees. I move again. It appears to have dropped by another 10 degrees. We know that every mile you travel, every degree you travel is about 69 miles. Each one. So every 10 degrees is 690 miles. These guys are moving, so the sun's dropping 10 degrees at a time. But suddenly they're not moving, they're not the same distance apart. The distance is greater. Now, if you've got parallel light rays on a curved surface, guess what? For every 10 degrees, it will drop. It will be the same distance around a curve.
We've all established the sun's rays are not parallel, but
they are all but parallel.
You're literally taking a measurement, two straight lines from a vertex, over an arc. That sextant index arc is the degree measurement you're taking. That's why you closed, what I said, the celestial sphere, and that's why you have your linear relationship on a flat Earth, because that closed arc linear reading is parallel to the horizontal of the scope.
Would you like some dressing with
It's
that
the
word
mechanic-
salad?
It's the mechanics behind how a sextant operates, how it works.
Is it?
If you didn't have it, yeah.
It's a
You-
shame.
you-
It's a shame that
let's-
sailors and that would disagree with you. Then people who actually use it or know how to use it.
Okay, let's say if we took that arc on a sextant and we made it a straight angle, not an arc, would you get the same readings?
Well, Well, so instead of that curve, if you had like a ruler,
Yeah,
you could
Would
do
you get the
that.
same readings?
But then the readings.
Would you get the same readings?
Well, if you let me answer,
No, you wouldn't.
if I'm looking, let's go back to the picture.
Okay.
So this one, right. So there's your picture. Okay, you've got your index arm. Now, if that scale that's curved was a straight line, well, quite apart from the fact you wouldn't be able to swing this, but let's make the arm a lot longer so it could swing past it. Then the actual measurements, you could have those measurements on a straight line, but they would get further and further apart.
Do you understand what's happening? So it's the
Yes, I understand what's happening. You have no bloody idea what you're talking about, Flatzoid, at all. Sorry, I don't wish to be rude, but you don't.
You just validated my argument like word for word there, mate.
Is it?
Yes. Oh, but I got another set at
Super chat.
and then
Okay,
we've got
go.
to close off because it is quite
Okay,
late.
yeah, that's fair enough. I have enjoyed this.
It was nice. I enjoyed it. It was nice and
Oh,
cordial.
good.
Awesome Lawson Clip says, channel support and shout out to Mr. S for coming on and being cordial. Enjoy the convo. Oh, and welcome to Flat Earth, Mr. S.
Well, thank you for the appreciation. I appreciate that. I'm not quite a flat earther yet, anyway. Flatzoid might have to do a bit more to persuade me of that one.
But no, I think it was a nice chat, though.
Yes, it was.
I'm happy we at least agree on something, that accelerating Earth is just stupid.
Yes, yeah, absolutely. There's nothing to support it. As a possibility, it's a possibility. Only there is no evidence whatsoever to support it, and just with Occam's razor, it's not the simplest solution.
Can I ask you one question then, quickly before we
Yeah,
close?
go on.
When someone, let's say, drops a lighter, you would say it's measurable and observable that the lighter is falling towards the ground?
So, as a cigarette lighter,
Yeah.
yeah. So you drop an object, it falls towards the ground. Is it observable and measurable? Yes.
Great, okay. Dal thinks to say, no, we making the claim that it's falling.
I see. But then we're talking about the
that principle.
Yeah,
Yeah,
back where we started. Perhaps a good place to finish. All right, listen, Zoid, thank you very much. It was enjoyable. It's good to talk to you again, and I hope you and your family all stay safe and well.
Awesome, you too. One more super chat for you.
No.
Triple, thank you very much. It says, if you truly love King Charles, Mr. S, say it's flat.
I think old Charlie Boy's all right. It's better than certain other possible world leaders who shall remain nameless. Anyway.
But thank you very much for the stream.
Yep, my pleasure. I enjoyed it,
time.
and I thank you too.
Yeah.
All right.
I thought tomorrow night, Wednesday is going to be Mactoon, but it's next Wednesday, so.
And
that's on Celestial Navigation, so do stay tuned with that.
Yes. Yes, so that'll be interesting. I'll have to keep a close watch on that one then. It'll be interesting to see if he has. What I'll do is I'll let him know about this stream so he can have a look, see what he reckons.
Yeah, you can do that.
Okay.
Let him prepare himself.
Yeah, and perhaps it will also save a bit of time that he doesn't have to go over certain things that we've already gone over if he agrees with me, and he can perhaps take the argument further forward.
Yeah.
Okay, cool.
Definitely.
All right, thanks again, my friend, and we'll catch up again sometime soon, yeah?
Awesome. Thank you very much.
Cheers. Good night, man.
Cheers. Blessings.
Bye-bye. Well, how's about that then, boys and girls? I did try it earlier on, but I didn't quite get it to work, so I think I ought to try this again.
I'm a South African. You can clearly hear I'm a South African.
Diplomatic community.
It's just been revoked.
Well, that was interesting. I did enjoy it. I do like talking to him, but there's some real confusion there. But at least we see where they're getting this. You can't, or you need a flat surface, because they think the co-altitude angle is the angle at the top by the star, which isn't an angle because the star's light's just coming parallel. That was fun. I see Rachie0000. How do you come up with a name like that then, Rachie? Is in the house. Who else got? Martin H. Colon, third. Regular names, Jeff C. Mary Ann the Night Owl. Mr. S is trying his best, but Flatzoid is totally not hearing it. Yeah. Do you know, I'm going to watch this back tomorrow. It's very hard to... I mean, he was almost there. About the sextants, he seemed to get it. We had a bit of an argument about the artificial horizon, but we got an angle of elevation. We deduct that from 90, as in how far off of vertical it is. But he's digging out an angle somewhere else. And, yeah, very strange. But there we go. I hope you've all enjoyed. How long have we been going? I don't know. How long have we been going, people? Do we... I can't see. We started at 10, didn't we? Oh, 2 hours 20. It says, now would be a good time to insert adverts. No, I don't think we'll do that. Yeah, so I actually got caught up, that's the word, with going through all that stuff, and I wasn't able to watch the chat at the same time. I'm sure there's lots of really good comments. I'm definitely going to watch this back with the chat and see what you guys were saying. I just having a look. Yeah, an angle of 10 degrees means we're off by 10 degrees from the GP of the star. 1 nautical miles, 1/60th of a degree, 1 arc minute. So 10 degrees off means we're about 600 nautical miles from the GP. And that's it. All we're saying is how far away are we around a circle from the point on that circle that star is above. And as I said, if the Earth was a glass sphere, so we could see it wherever it was, if you could see it 180 degrees from your zenith, i.e. straight down, you know you're on the opposite side of the Earth. If you know the size of the Earth, you know how far away that is. If you can see it, it's down there and it's at 90 degrees to my vertical, you know you're a quarter of the way around the Earth. We know how big the Earth is, you know how far away we are. That's all it is. But we're not working with 90 plus degrees, we're working with smaller angles because you don't use stars that are close to the horizon because of refraction and so on. It's not difficult. I actually toyed with the idea, I don't know if I said this before, toyed with the idea of doing a mock-up using a little model on a kiddie's roundabout, using the sun as my only available parallel light source to try and demonstrate how it works. But I don't know. Will they get it? Who knows? So yeah, we're at 12:22 BST right now, and I think I'm going to draw a line under it. Thank you very much for joining me. I see we've got 100 now. I don't know what the peak was. Not going to tell me. Don't forget to hit like, though. And if you haven't already, consider subscribing. I like that. I do like that. Massive thanks, as always, to all my members, my patrons, everyone who's kindly super chatted. I appreciate each and every one of you. And those who aren't members, those who aren't patrons, those who haven't super chatted, I love and appreciate you too. So stay safe, stay sensible. Good night.
Mr. Sensible, bring me some cheese, and get me only the best if you please. Here are some flowers, let me display them. Yea, Dr. Warner, you have Arnold slay them. Mr. Sensible, you are a man. Every subscriber is a faithful fan. Bring your logic and your cheese. Mr. Sensible, help us out, please. Mr. Sensible, I needed proof of gravity, so I jump off the roof. It's hard enough, let me go further. Why was I ever such a darn flat earther? Mr. Sensible, I'm such a clown. I am the laughing stock of the town. Bring your logic and your cheese, Mr. Sensible. sensible. Bring me a sphere, to which the waters of the oceans out here, have explanations that let me be candid. So clear that